Question 16 is about verifying trigonometric identities. It is the first in the writing part from the lesson 11.2. Here these are some basic formulas which you must remember, especially the Pythagorean identity. Remember the different variations of this. Say cosine squared theta equals 1 minus sine squared theta and so on. These are all basic identities, reciprocal quotient identities, Pythagorean identities. These will not be used much. You might use these Pythagorean identities and mainly the reciprocal and quotient identities. We will look into a problem. Now, this part of the problem, you should know they both are equal. They are identity. No matter what, we have to prove them. If you take your calculator and put theta as 30, both the sides will match each other. But that is not what we are doing. We have to transform it and get both the sides equal to the same term. How do we do it? There is a thumb rule. See, thumb rule. So, thumb rule 1. This may not work for all 100% of the time, not all the problems, but most of the problem. Thumb rule 1, get into sine theta and cosine theta from sine theta and cosine theta. Get all these terms into sine theta and cosine theta. What does this mean? Whenever you see this, okay, sine, leave that. Don't go to simplify that. Cosine, don't go to simplify that. Where you can see anything other than these, try to get them in terms of sine and cosine. Let me show you. Step 1 here. Let's take the left hand side, LHS. Let's transform this. What is secant exactly? It's 1 by cosine theta, right? Minus, what is tan theta? It is sine by cosine theta. Sine theta by cosine theta. Okay, now I can easily tell this is done. You don't even need to transform the left side. So here, you can, if you can see the denominators, cosine, it's the same thing. So I can write cosine theta together and this will be 1 minus sine theta. That is equal to the RHS. Done. It's proved. This is a very simple problem. You may not get this in exam, but this is just a basic one. When you just try to transform these left side into sine and cosine, you automatically got the right side. Or if you wanted, you can even transform this side. If you wanted this, step 2 RHS. Say you got confused with this step. You don't want to do this step. Fine. Split this cosine to both the terms. 1 by cosine theta minus sine theta by cosine theta. Now what is it? Both LHS is equal to RHS. Step 3 would be compare both the sides. Okay, step 3 is compare LHS and RHS. Hence, it is an identity. Equation is an identity. That's it. This is a simple one. Let's go to more complicated ones. Here the step-by-step solution is also there. You can refer to it later. What about this problem here? Now again, I'll stick to the same thumb rule. Whenever I see terms other than sine and cosine, I try to simplify them. 1 plus step 1 here, LHS. What am I going to do? Tan is sine theta by cosine theta divided by sine theta plus cosine theta. See, the right side, we don't have much to work with. So we have to get this simplified now. You can see it's a whole number over here. There is a fraction. So what we can do is we can get the denominator same. How do we get this denominator over here? There's nothing. It's a 1. So multiply and divide by cosine theta. So when you multiply and divide by cosine theta to this 1, now you have a denominator of cosine theta. What happens over here? It's cosine theta divided by cosine theta plus sine theta divided by cosine theta. This entire thing divided by sine theta plus cosine theta. Now when we have same denominator, can we write it together? Yes, we can easily write it up. So cosine theta plus sine theta divided by cosine theta. The whole thing divided by sine theta plus cosine theta. Now here, this is the upper term and this is the denominator. It's, if I write it in terms like this, a by b divided by c. Okay. How do we simplify this? If you want to write them together only in numerator and denominator, this is going to be, this b falls down, isn't it? So it'll be a by b and c. So this is what's going to happen. And then if we have a and c, we can simplify them if there is any common term. Now if you look carefully here, sine theta plus cosine theta and cosine theta plus sine theta is the same thing. So I can cancel this off. Why? Because this denominator, this one will move down over here, and these both are in the denominator part. So what happens is, this is basically the denominator, right? The numerator cancels the denominator, they are same. So what is remaining now? It is basically 1 by cosine theta is remaining. What is 1 by cosine theta? It is secant theta. I have not used the right side. This is fine. You can stick to one side and solve to the other side. It's absolutely fine. And here we go. This is the answer. So that's it. These are the steps. Now we can do more elaborate steps using both the sides, but whichever you find it easier, just stick to it. Now this one was pretty simple as well. Only the part is, over here, you need to make sure that you get the denominator same. Cosine theta, and then you can have a common denominator, that is cosine theta, and above it will become cosine plus sine, and it cancels off. So that's how we solve this up. And here we see, you can start with the left hand side, and over here they have left it over here, and then they have gone to the right hand side and simplified it further as well. Over here this cancels off. The steps which I did was much easier than the solution over there. And this one over here, this is another problem. What do you want? Oh, there are 32 problems. So it's going to be a long video. So do bear with me. I will try and solve all the problems, all the 32 problems. If you're thorough with this, just stop watching the video anytime you want and just practice it by yourselves. Now, what about secant theta, cosecant theta equals tan theta and cotan theta? Secant is 1 by, sorry, it's cosine, cos theta, and multiplied with cosecant is 1 by sine theta. That is equal to tan theta is sine theta by cosine theta plus, what is cotangent? It is cosine theta, inverse of this, reciprocal of this, sine theta. Now then, what can we do over here is, let's try and simplify the left. Okay, this is another way to solve as well. It's a writing exam. You can solve it any way you want. You can start left and right side simultaneously, which I'm doing over here, or you can do left side separate, right side separate, whichever is easier. I personally follow this, solving left side and right side together, because I'm just writing it out and we can easily solve it. Now, left side, it's just multiplication. So I'll write sine or cosine, it's fine, whichever you can write it first, multiplied with sine theta. That's it. I'm not going to touch this much because I don't have much to work with. Here I'll leave this over here itself. What about this one? Can I take the common term? But this doesn't have cosine, this doesn't have sine. So what I'll do is I'll multiply this denominator up and down. That's cosine theta by sine theta. Sorry, it's the same thing. Cosine theta. This is cos theta. And what about over here is sine theta by sine theta. So what we have over here is, see, if we write it properly, it's going to be sine power 2 theta divided by sine theta cos theta plus cos squared theta by sine theta cos theta. Next, we can add them up, right? Sine squared theta plus cosine squared theta divided by, the denominators are same, so I can write them up together, sine theta plus cosine theta. Over here, I can write anything first, so I'm going to write sine theta, cosine theta. You don't need to do it, but I'm just doing this step. Now what happens? What is sine squared plus cosine squared? Pythagorean identity says it's 1. So 1 divided by sine squared theta plus cosine theta, 1 by sine theta, cosine theta. This is also the same thing, isn't it? You don't need to write it again and again over here. Over there only it's enough, but I'm just writing it over here. See, left hand side is equal to RHS. Therefore, The given equation is an identity. You can write this. The given equation is an identity. Is an identity. So this is you'll get full marks for this if you write so much. So you can write it in stepwise or directly, you can just write LHS and RHS. Don't write over here equal to, because they're not equal. We need to simplify and then we can tell it's equal. So this is how we can solve this one. Let's look into more problems over here. Here as well, all the worked out solution is there, and then you can just compare both the sides, and here we go. The next problem over here, we have 2 sine square theta minus 1. There is sine theta, cosine theta. Okay. Now you can start from here, but it's going to be very, very difficult. You can see there is already a square at the right side, right? So here we have to do some manipulation. This denominator, take it to the other side, and then if I start multiplying, I'm going to have a square. Otherwise, there is no way I can get a square, right? I have to just multiply sine both the sides, and it's just going to be complicated because there is sine over here. So what I'll do is this, I take it to the other side. What's going to happen? It's going to be sine theta plus cosine theta multiplied with sine theta minus cosine theta. That is equal to 2 sine squared theta minus 1, isn't it? Here, what identity can you use? It's like a plus b, a minus b, that is equal to a squared minus b squared. Or you can start multiplying like distributive properties. Sine times sine, it'll be sine squared. See, both of them can be used. I'll do it by multiplication, because if you forget this identity in the exam, I can't directly write it. So sine is multiplied to both the terms. It's going to be sine power 2 theta minus, because there's minus here, sine theta cosine theta, plus this is multiplied to both the terms, cosine theta sine theta minus cosine and cosine will be cosine square theta. Now this minus and plus can be cancelled off. So what's remaining is sine square theta minus cosine square theta. Now when you have the same terms repeated but plus and minus is there, we can use the term. The first term over here is squared minus the second term squared. So directly we can get it from the identity without this step if you know the identity. So that is equal to 2 sine square minus 1. Is it true? No, but we have sine square here. What can we do? How can we remove this cosine square and get in another sine square? Because we need 2, right? So what I'm going to do is, I know the identity of Pythagorean identity, sine square theta plus cosine square theta is equal to 1, isn't it? So this is the identity, is equal to 1. Now I'll remove this sign to the other side. It's going to be cos square theta equals 1 minus sine squared theta. So can I substitute instead of this cosine 1 minus sine squared? Because I need sine squared theta here. There's no cosine. So I'm going to remove this off. So it's going to be sine squared theta minus, open the bracket, because cosine is 1 minus sine squared theta. That should be equal to sine squared theta minus 1. Let us multiply the minus sign here by distributive property. So it's going to be minus 1 minus minus becomes plus sine squared theta. Now sine and sine, there are 2 signs plus right over here. Both are positive, so it will be 2 sine squared theta minus 1, which is equal to the right side, which was also 2 sine squared theta minus 1. So left hand side is equal to RHS. This is an equation and an identity. This is how we solve it up. Here, yeah, that's it. So just make sure you remember this, because we could not do anything at the left side to get in terms of squared. So we just take this below term to the other side and multiply, and we'll get a square, and then you can manipulate it a little bit and get the answer. No matter what, these are identities. They have clearly mentioned, verified each equation that each equation is an identity. So you can use your calculator as well. Put some angles, say 30 degrees everywhere. Both the sides will match. So here is the worked out solution. You can go through it in your own time. You can pause the video, go through it. And here as well. Okay, instead of all that, just follow the method which I did. That was more than enough. Here we have sine theta plus cosine theta whole squared. Now, when you have this whole square, there is no way you can do it without the identity. So the identity of a plus b, the whole squared formula is a power 2 plus 2 times ab plus b power 2. If this was minus, this middle term becomes minus 2ab. Now it's all positive over here because it's a plus b, the whole square. So let's use the identity. The first term becomes squared, that is sine squared theta plus 2 times sine theta, and we have cosine theta, and plus cosine squared theta. So this is the simplification of the left side. Now what can we do with the right side? Wait a minute, I can even simplify further over here. What is sine squared plus cosine squared? It's 1, right? See, if I write this up together, sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Here this becomes 1 plus 2 sine theta cosine theta. So this is the simplified version of the left side. Now let's see the right side. What can we do over here? This is equal to, here what we have to do is first apply all the reciprocal identities and get in terms of sine and cosine. That's the thumb rule, isn't it? Here secant becomes 1 by cosine theta multiplied with 1 by sine theta. Divide this entire thing by again 1 by cosine theta multiplied by 1 by sine theta. Now here when we simplify, I'm just gonna, it's better to do this as step 1 LHS, step 2 RHS, the right hand side, because otherwise it'll be messy because there are many steps for each of them. It's not the equal steps. Now here what we can do is, we can find, see the common denominator, we can just write it up together, 2 plus 1 by sine theta cosine theta. Now what about this below 1? Same thing, it'll be 1 by sine theta cosine theta. But here this is the problem. This denominator, we need to get it as common, but it doesn't have anything. So multiply this up and down. It's going to be sine theta cosine theta divided by the same thing, sine theta cosine theta. And now what we do is, we have the common denominator, so we can rewrite them together. So here it will become 2 sine theta cosine theta plus 1. Why? Because these two are having the same denominators now, and divided by sine theta cosine theta divided by again 1 divided by sine theta cosine theta. Now here, look, this is in terms of a by b divided by c by d, isn't it? Can we cancel b and d? Yes, absolutely, because if we write them up together, if this goes up, it becomes a reciprocal, right? A by b multiplied by d by c. So these two will join up together and these two will be up together. So here b and d can be cancelled if they are same. Now the same thing is happening here. B and d, they're same, so I can cancel them off. And what is remaining here? I'm remaining with 2 sine theta cos theta plus 1. What about the left side? I'll write 2 sine theta cos theta first plus 1. It's the same thing. So left hand side is equal to the right hand side. Hence this is an equation and an identity. So that is how we solve it up. And we can see the steps as well. You can go through this later. You can just pause it and you can go through it if you want. And that's how we solved it. Now we are in 24th, still plenty of problems to go. I hope by now, if you have understood, you're solving these by yourselves. Only if you want to, if you got stuck somewhere, then you can continue watching the videos and see how it is done. Now here in this problem, we don't have much to work with because it's cosine, sine, sine, cosine. Now, in such cases, don't be stuck. There'll be something to work with. Over here, you can see denominator is 1 minus sine theta. Whenever you are 1 plus sine theta in the denominator or minus sine theta, not in the numerator, when it's in the denominator especially, or even in the numerator, we can do it. We have a conjugate method. That means, see, look at this, cosine theta by 1 minus sine theta, right? I have to multiply it and divide with the conjugate. That is the same two terms but the opposite sign. So I'll have to do 1 plus sine theta over here divided by 1 plus sine theta over here. Why do we do that? So now here it is a minus b, a plus b. We can use the identity a square minus b square. If you start multiplying it, you're remaining with only the square of the first term minus the square of the second term. So here we have cosine theta that is multiplied with 1 plus sine theta divided by 1 square minus sine square theta. What is 1 square theta? 1 square, sorry. It's 1 itself, isn't it? Cosine theta into 1. See, now, keep your eye on the right side as well. I got 1 plus sine theta already, so that is a good thing. Now, we don't have to bother about that. I'll keep the cosine outside. I'm not going to multiply it inside. Here I have 1 minus sine squared theta. Now, what is 1 minus sine squared theta? From Pythagorean identity, we know this is cosine squared theta. So, cos theta into 1 plus sine theta divided by this thing is cosine squared theta. This cancels, and you're remaining with 1 plus sine theta divided by cosine theta. That is equal to the right hand side, isn't it? I didn't even have to touch this. I got this answer. So this is how we do it. There is another way. You can even multiply the right side with 1 minus sine theta by 1 minus sine theta, and then you will ultimately get this. See, the denominator, this is there. Here it changes to cosine squared theta, cancels off, and you will get this answer. So whenever there is two terms, remember to use the conjugate, and that is how we can solve it up. Here we can see the methods are all there. Now here they have they've used different methods, a little complicated. No need of this. Whenever you see the two terms, just use the conjugate. That is generally how we can easily solve it up. And then they're comparing the two sides. Okay, it's just too lengthy over here in the solution set. But this one, which I just now showed here, is pretty easy compared to that. 25th problem. So after this, there's 7 more to go. Cosine theta, that means let's get it in terms of sine or cosine. Sorry, it's not cosine, it's cosecant. It's 1 by sine theta minus 1. That is equal to, what is this? It is, cot is cos squared theta by sine squared theta divided by over here 1 by sine theta plus 1. Now just remember, when we are solving these, there are various different methods to solve this. Which I am doing is just by following some thumb rules and just going on. There are other methods as well. Now over here also you can try conjugate and whatnot. You can do that. There are plenty of ways you'll get the same answer. You don't need to stick to the method which I'm teaching, but I feel what I'm doing is as simple as possible. You know, sometimes it might be longer, but it might be easier as well at times. So here, this is done. So what next? I have 1 by sine theta minus 1. Over here there is, I can remove it to the other side and do a lot of things. But before that, okay, whenever you see like this, same term minus and another term, same term plus another term. It is very easier if you move it to the other side. Then we will have 1 by sine theta minus 1. This is one term. 1 by sine theta plus 1. See, there are some hints whenever you see such things, you know, you can do that. Also, you can do the conjugate here. I'll do that other method as well because now I realize there is two terms. We can do the conjugate here. But you need to know Pythagorean identities of cosine square theta and stuff. Now here what is remaining? It is cos square theta by sine square theta, right? So what about this one? Let's multiply, I mean, not multiply, it is a minus b, a plus b. That is a squared minus b squared. So here it will be 1 by sine squared theta minus, what is the second term? It is 1 squared. Now here, we are not yet done, is equal to, this is, let's leave it for now. Whatever this over here we have must be brought to this term. Okay, what is this? This is 1 by sine squared theta. 1 square is 1 itself. Now let's take the common denominator. What do you do? Multiply and divide by sine squared theta, right? So here you multiply sine squared theta and divide by sine squared theta. So the denominators are same, so we are getting here sine squared theta in the denominator, and we will have 1 minus sine squared theta. What is 1 minus sine squared theta? It is cos squared theta by sine squared theta. Now it's equal, right? That's how it is. Now there are other ways also. What I was telling is this here, conjugate method. What conjugate? Now you don't need to do a conjugate method because this is there. You can just multiply it up over here. So it'll be cosecant. See, now here, without changing it to sine and cosine also we can solve. But as a thumb rule, I always change it. So I did in this method. But over here, what's going to happen is cosecant theta minus 1 multiplied by cosecant theta plus 1. That is equal to cot squared theta. Now here it's going to be cosecant theta squared over here minus 1 squared. That is equal to cot squared. And what is cosecant squared theta minus 1? If you remember from Pythagorean identity, cot squared theta plus 1 is cosecant squared. So if we take minus to the other side, this is going to be cot squared. Because cosecant squared theta minus 1 is actually cot squared itself. So cot squared theta equals cot squared theta. So now here, because I could recognize the Pythagorean identity format here, that's why I went with this. Otherwise, you can get it in terms of sine and cosine and then solve it up. Still, you will get the same answer. But this was the extra part, you know. But we have done the similar thing previously as well. So whichever is easy, you can go with that. And here you can see, here also they have gone with sine and cosine. And then, you know, compare both the sides. So here, that's the answers. Okay, it's again long. And we will look over here, comparing both the sides. Finally, they got both the sides as equal, and that's why that is an identity. Now, what about this one? We have cosine, cotangent. Now, cosine theta, I'll just go with the thumb rule over here because I can see cotangent, cosine, and there's nothing easy to solve. There's no power 2 or anything. So this will be cosine theta by sine theta. What about this? It is 1 by sine theta minus sine theta. We are over here, it's very simple to find the common denominator because it's multiplied, isn't it? So down, it's only 1 sine theta. Up, it will be cosine squared theta. What about this one? It will be 1 by sine theta. Here, you have to multiply and divide by sine theta. Why? Because up here, sine theta is there, but down there is no sine theta. So you have to do up and down. So it will be minus here sine squared theta by sine theta. Now we have the same denominator. So what's going to happen? Just write it once. Don't multiply this. It's minus here. So minus up, but denominators will be same. So if you're getting confused like this, imagine you have 3 by 9 and minus 4 by 9. You just solve the above terms, right? It will be 3 minus 4 divided by 9. The answer will be minus 1 by 9. Whereas if it was multiplication, it's altogether different. You know, you just write them out, cancel it out together. That's it. So when we have same denominator, we can write them together only once. And whatever is the operation up above, we write it above in the numerator. So the same thing. This we write it only once, and up is 1 minus sine squared theta. Now what is 1 minus sine squared theta? This cosine squared theta by sine theta. Is it correct? Yes. The left hand side is equal to the right hand side. Hence, this equation is an identity. This was pretty simple. And let's look into, okay, you can just pause it and go through it later on. That's the answers. Okay. We are in the 27th problem. Sine theta, cosine theta, tan theta plus cos square theta equals 1. Here sine, let it be as it is. What is cosine? Also again, same thing. What is tan theta? Tan theta is sine theta by cosine theta. Then we have cosine square theta. Here, what happens? This cosine is cancelled. What happens? Left side is sine square theta plus cosine square theta. Now here, look at this. Yes, left side, what is it? Pythagorean identity. Yes, it is equal to 1 is equal to 1. LHS is equal to RHS. I was thinking this is going to be a big problem because it was plenty, over here, many terms. But in fact, this is such a simple problem. All you did is tan theta formula, cosine cancel, sine squared plus cosine squared. This is 1. And even the right side, they want us to solve it for 1. So yes, this is an identity as well. Again, here you can see the same thing. They're splitting the terms and then getting it as 1. And conclusion, yes, this is an identity. This has been a very long video. If you're watching until over here, that means you're going to get great marks. I mean, you're trying very hard. That's very good. And if any one of my students from Aluruba is watching till here, let me know tomorrow, anytime this week, and I'll definitely give you some bonus marks, at least 2 bonus marks, because I would be really happy if you come till over here. I'm sure most of my students have skipped long ago. So if at all any of Aluruba students have watched till this part, then please let me know and I'll give you some bonus marks. Okay, going on to 28th problem. Now here we can see there is whole power 2. So it's like a minus b the whole power 2, right? But instead of that, first let's simplify how much we can, because it's cosecant and cotangent. And the thumb rule is to get in terms of sine and cosine, isn't it? So here it's 1 by sine theta minus, it's not sine. Tan is sine by cosine. This is cosine theta by sine theta, the whole squared. Let me try to simplify how much we can over here, because sine and sine, we can write it as common sine theta and 1 minus cosine theta. Okay, now what else we can do? We can split, no, this is already done. This is the whole square. Now, how about I'll split the square? I can split the square how? For the numerator and the denominator. See now, a by b the whole square. What happens? A squared by b squared, right? Same thing. I'll just split the square. It'll be 1 minus cosine theta, the whole squared, by sine squared theta. Why? Because this down also is power 2. So I can, whenever we write, see, sine theta the whole power 2 is equal to sine squared theta. We just write it over here for the sine. When it's whole thing, we just write sine squared theta in writing. Now then, how can see, right side we need 1 minus cosine theta. Okay, this is good. What we can do is we can split this out. See, what I'm doing is 1 minus cosine theta whole square means it's 2 times, isn't it? Again, I'll write 1 minus cosine theta divided by, over here, sine square theta. But look, I need cosine only. So from Pythagorean identity, I can write 1 minus cos square theta is equal to sine square theta. So I'll do that. So what I'm going to do over here is I'll write 1 minus cos square theta. Now look over here, there is square, there is no square. How can I split this? Look, a minus b, a squared minus b squared is a plus b, a minus b. So I'm going to use the same identity. This 1 can be written as 1 squared. It's the same thing because it's 1 itself, right? Now a squared minus b squared will be a plus b. That is 1 plus cosine theta and 1 minus, sorry, it's a minus b, minus cosine theta. And up above we have 1 minus cos theta and 1 minus cosine theta. So can we cancel? Yes, this can be cancelled. And is it? Yes, absolutely. We found the answer. It's 1 minus cosine theta by 1 plus cosine theta. This is the right hand side. So LHS is equal to RHS. So this is how we do it. I hope this is clear. That's the end of this problem. It was a lengthy one. It's not that difficult. You should just use the thumb rule. Always get in terms of sine and cosine and simplify how much you can. And now you look at the right side. What do we want is, above it's fine. This one needs to be in terms of cosine. But here we have squared, so we can use the a square minus b square formula. Split it out. The terms get cancelled and you get the answer. See, as you put in the right formulas, eventually it will simplify to the other side. As you keep on continue to solve, it will come to the right side. So here we go. You can pause and watch this. Here also it's the same method. I mean, little variation is there. That's it. Okay. And here we go. This is a long one. Okay, they are comparing both the sides. Finally, they got the same thing. Rather than that, what I did over here is I took the left side and just straight continued till I got the right side. This is also absolutely fine. And this is a little easier because you don't have to simplify this to some steps. This one, no. I just took this one left side and came until over here. And here we have the next problem. Again, cosecant square theta. Cosecant is 1 by sine. Now square is there, so 1 by sine squared theta. That is equal to, what is cotangent? It is cos square theta by sine squared theta plus sine multiplied by sine theta multiplied by 1 by sine theta itself. So here I can just cancel this off, right? Why sine and sine cancels off. So here what do we have is okay, now rather than doing this, I just realized the power 2 is very helpful. See, we can continue like this as well. We can find the common denominator. You will get the same answer, but rather than that, there is such a easy method here. What is that? Here, if I keep it as cosecant squared theta equals cot squared theta. Now what happens here? These both are reciprocal and became 1, right? This is plus 1. Now look at this. Yes, this is identity. Cosecant squared theta means it's cot squared theta plus 1. This is the Pythagorean identity, isn't it? So we can just say that it's the identity, or we can tell this is also cosecant squared theta. That's the identity. So it's not required to simplify. Even if you simplify, yes, you will get. Now here, that is the reason why I told the thumb rule works almost all the problem, not every problem. Here in this, you can do it like this, but it just takes you more steps. Rather than that, whenever you have power 2s like this, think for a minute. Simplify some of the parts, and then you can easily get the identity, then just stop it over here. In fact, for this problem, if you write this, you don't need to write this step. You just write this part here. Get this part over here. Say CSC squared theta equals cot squared theta plus, now sine theta multiplied by 1 by sine theta. And then if you write so much, write LHS equal to RHS. You must get the full marks. No need of this one. Just these. Even over here 2 and the third one is more than enough. You should get full marks for this. So that is how we solve this problem. Here they have used a similar method, yes. And it's a little complicated here. But just use whichever is simple and which you are finding it easy. And yes, both the sides are equal. We're going to the 30s now, 30th problem. Here, secant. Secant is 1 by cosine theta minus 1 by sine theta. Now this is going to be taking common denominators. It's again 1 by sine theta multiplied by 1 by cosine theta. That should be equal to sine theta minus cosine theta. Now here I need to multiply sine theta by sine theta, so that I'll have the same denominators. Over here, what do I do? Multiply it by cos theta by cos theta. Well, because here cos theta is this, so this multiplies up and down in the other side. Sine theta is already there in the denominator, so it goes to the other side, up and down. Next, what we do is we just simplify how much we can. It'll be sine theta divided by sine theta cosine theta minus cosine theta divided by sine theta cosine theta. Entire thing is divided by 1 by sine theta cosine theta. Now here the above term is sine theta minus cosine theta divided by sine theta cosine theta. Why? Because these two are the same denominators. We write it up once, this minus here and left term and the right term. This entire thing is 1 by sine theta cosine theta. Now we have got similar problem just a while ago. We can easily cancel these both because this swaps and goes up to the numerator and 1 will be in this position denominator. So this and this cancels. You're remaining with sine theta minus cosine theta. Here LHS is equal to the RHS and hence proved. So that's how we solved it out over here. Let's look over here how they have solved it the similar way. Even over here, see, generally the same thumb rule is used. Whenever you have anything other than sine and cosine, you apply the reciprocal identities and try solving it. So over here, yeah, you just simplify it and you get the right side. So we compare, both are same. What do we do over here? See, this is sine square theta plus cosine square theta. This is equal to 1 left side directly. And what about this one? Secant square theta is 1 by cos square theta minus tan is sine square theta by cosine square theta. Now the denominator cosine square theta is together 1 minus sine square theta. Now what is 1 minus sine square theta? Now here, since the denominators are same, I wrote it together and 1 minus sine square theta. 1 minus sine square theta in Pythagorean identity is cosine square theta divided by again cosine square theta. Cancel this off, you'll get 1. Left side is already 1. Yes, LHS equals the right hand side. So this is how we solve it up. They're all pretty simple. Once you start solving a few, then you'll get a hang of it and then you can easily solve them up. And here you can see the left side and the right side, both will become 1. And yes, that's it. That's the answer. Okay, you can use other identities as well. Here, okay, they have just split this up. Secant square theta is 1 plus cosecant square, right? This minus and plus goes, so 1 remains. Even this is absolutely fine. But you need to know the Pythagorean identity of secant square theta. Now I remember, but when I was solving it just didn't come to my mind. But what I did over here is absolutely fine as well. And comparing both the sides, they are equal. Finally, the last problem in this topic, 32nd one. Let's do it very quickly. 1 by cosine theta minus cosine theta must be equal to, this is sine by cosine. That is equal to sine theta by cosine theta multiplied by sine theta. Now remember one thing. Once I remember, it's not now a long time ago, maybe the last year when I was doing the EoT or something, I had actually taken one single identity wrong, reciprocal. I can't remember exactly where, but I had gone solving it almost till the end and I was not figuring out. Only one was the issue. But then I realized, okay, initially I had missed one single formula. You might continue, you might feel, okay, I'm getting it right because it's almost there, but you're not getting the correct answer. It might be to do with the formulas. So be very careful, check the formulas thoroughly before writing, and then continue. When you go to the next step, just double check everything. Yes, this is 1 by cosine, this is sine by cosine, and so on. Now we have to take the common denominator here. See, I'll write over here generally what we do is cosine theta minus cosine theta. We multiply and divide by cosine theta, that is this denominator, right? And then we can see this denominator is same, so we'll write denominator same, cosine theta. 1 minus cosine and cosine will be cosine square theta. But you can directly get this as well. There is a trick. This is no denominator. This has the denominator of cosine theta. So what you do is write the denominator here, cosine theta. Then this numerator of this is just written 1 minus. Now here this is written as it is. But to balance out the equation, you multiply this denominator to the numerator here. When I multiply cosine and cosine, there are two cosine. I can just put power 2. So I can directly get this. And equal, or you can just continue this because we have done it many times. Now here it's sine and sine, it is sine square theta by cosine theta, and 1 minus cosine theta is sine square theta by cosine theta. That is equal to the right hand side. So yes, this is also proven. LHS is equal to the RHS. Now if you write so much, you should get full marks. Nothing, no issues over here. That's how we solve it up. You can see over here the steps as well. The same steps, you can go through them. And that's okay. The steps over here are plenty, I think, so you just follow what I did. It's pretty easy, you know. Okay, finally, it is done. Both right hand side and left hand side are balanced. So this is how we solve this up. It is a bit lengthy, but just practice writing. Write more problems, solve more problems by yourselves, and then this is going to be pretty easy. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. Question number 17 is to solve trigonometric identities. This is an interesting topic. Now looking at this equation, we don't have much to work with. As you can see over here, there is sine square and right side there is sine. If you're substituting identities, how would you solve this? So you know the sine square identity would be 1 minus cos square theta. But if I substitute over here, will it help me at all? No, it will just make it more complicated because there is another square and two different trigonometric functions. So that is not going to help. What I will do is, I'll just write it all at one side. I'll bring everything at 1 and make the right side equal to 0. So it'll be 2 sine square theta minus 3 sine theta minus 2 equals 0. Now, let's try to, see what can I do over here. If you look carefully, this is power 2, this is just power 1, and there's a constant, yeah. So what can you do over here is, you can solve it as a quadratic equation. Now, instead of sine theta, I will just write it as x. So what is going to happen? It will be 2x squared minus 3x minus 2 is equal to 0. Now we can solve this easily using calculators, right? Quadratic equation. We will do that now. All you need to do is mod, phi, and 3. This is how we solve quadratics. When you go to mode, there is equation, that is option phi, and this is power 2. Only option 3 gives you power 2. And now substitute the coefficients. First starting with x squared, the coefficient is 2, then it's minus 3, and lastly the entire number, it's minus 2 over here. So the answers we got is x is equal to 2 and negative half. So here x is equal to 2 and x is equal to minus half. But is this x actually? No, it's sine theta. So let's substitute it back. It's sine theta equals 2 and sine theta equals negative half. Now, do you know what is the range of sine theta? If you know the sine theta graph, imagine you start over here, starts with 0, goes up to the maximum, comes down, and it'll be minimum, and it just continues the same, right? So the maximum is 1 here, minimum is minus 1. It can never have any other values other than 1 or minus 1. So here sine theta is 2. It's not possible. It's really wrong because sine theta can never be 2. So we can verify it by mode 1. We'll go back to the computing mode and let's take sine inverse of 2. It'll be a math error. So this shows you that it does not exist. But if you do over here, sine inverse of negative half, that is 1 by 2, you're going to get an answer that's negative 30. So here what you can do is the first one, you can tell it's undefined, it's not there, you can just ignore. So this is not there. You can just tell theta is undefined, sine theta is undefined at 2. And over here we get theta equals negative 30. Okay, so this much, I hope everything is clear here. It's negative 30 degrees, but this is not the answer. The problem is, when you know the unit circle, see this unit circle, which will be something like this, and you have 0 degrees, this is 90, sorry, 90, and over here it's 180, 270. Now, one more thing. If you look over here, the calculator is in degree mode. I've not changed radian because this is a writing question and there's no pi over here. So I'm doing everything in degrees because I find it easier to analyze things in degrees rather than pi. If you change it to radian, over here you should get 30 is pi by 6, negative pi by 6. So if you change it to radian, it will be negative pi by 6. But since it's writing, doesn't matter. Do everything in degree. And if they ask you to convert to radian, at the end, just convert it. I will tell you how to do such problems in a while. But for now, this is the unit circle from 0, 90, 180, and 270. Now, we need to know that there is something called CAST diagram, C-A-S-T. Over here, the fourth quadrant. This is the first quadrant, second quadrant, third, and the fourth. In the first quadrant, all are positive. That's good. But what is the second? Only sine is positive. Here only tan and only cos is positive in the fourth quadrant. First thing, here theta is negative 30. That means it comes like this, something like this. We don't take negative angles. We will convert to positive. So what is theta equal to in terms of positive? It will be minus 30 degrees plus 360. It's always to find the coterminal angle, you have to add 2 pi or 360, and theta is equal to 330 degrees. So now this is the thing. You can even check this answer. Look over here. If I press sine 330, I must get how much? Negative half. And yes, I'm getting negative half. So that's good. So I know 330 is somewhere over here. It is minus half. Sine will be only x, the sine, sorry, y values. Sine is negative half. But I know there is one more quadrant which will give me negative half itself. Is it the first quadrant? No, first quadrant it's only positive. So if I think so it is, if this much is the space, it will be sine 30. It should be half. Let me just show you. Sine 30 degrees is positive half. Now if I go over here, see, if you know the unit circle, you will get this easily, but I'm just trying to tell you the shortcuts here. It'll be something like this. Now, this one will be 150 minus 30. The unit circle is always at a span of 30. So this is 30, 60, 90, 120, 150, 180. This will be 210, 240, 270. Then here we have 300, 330. Sorry, that's not there. This is 270, 300, 330, and again we go back to 0, that is 360 degrees. This is the unit circle. Now, I know sine 30 is half. Even if I try this point, that is 150, it will be positive half itself. But I need negative half. So I will try this. One second, let me just put these two. This one is again half, and this one must be minus half. Now, this is because I know the unit circle very well, but even if you don't know, from this axis, see the difference is 30 degrees, right? Even on the left side, there must be a difference of 30 degrees. So I can easily understand it's either 30, 330, 150, or it must be 210. Let's check what is 210. It is negative half. So there are two answers here. Theta is 330, you will get negative half, and theta is 210 degrees also. The thing is, this keeps on repeating. If you add 360 degrees to it, again you will have negative half. If we keep on adding 360, it's going to be negative half. So we don't keep on adding 360, we just write 360 times k. K is an integer, it can be 1, 2, 3, anything. Even it can be minus 1, 2, 3. Because even if you subtract, keep on subtracting 330, you will get negative half. See, if you subtract 360, sorry, you're getting minus 30. That is also a possible answer. It's infinite possible answers, right? So we just write 330 and 210 plus 360 times k. Over here also you need to write plus 360 times k. K is an integer. This is understood. You can write k belongs to z, that is integer, short form for integer. So this is the answer. You need to write so much, you will definitely get the answers, because if you're writing this means you know the knowledge, you understand. Now you can add a sentence over here. From unit circle, you will get this. Now I'm sure you might have this question in your mind. Oh my god, there is no way I'm gonna get this 210 with the figure which I did over here. So I'll tell you one thing. This is a long procedure, but you can try this. You will get one answer for sure, right? Then just keep adding 30. See, 330 we can easily get from the calculator. Now you need to find when sine is negative half. You can try sine 30, no. Sine 60, no. Sine 90, no. Just multiples of 30. This might work, not in all cases, but many cases it will work. So 150, you got again half. I want minus half, not at 180. But now if I do 210, I get it. See, I already have this. I can go here. Otherwise, an easier method is if you just know the signs of sine. I know this is positive, this is positive. First and second quadrant, no. Start from 180. After 180, which is the value? 210. In the first attempt only, you'll get negative half. Only try these 6 values. You'll get it. Why? Because we got sine as negative half. So this is the way. So that's how we solve it. We can see the answers. Now over here it's given in terms of pi, that's fine. But these are the correct, over here both it's given, sorry, I realize now. 210 degrees plus k, they have written k first and then 360, it's fine. You can write it as 360 times k, both are fine. Now if you want to convert this to radians, if they mention in the question, write in radians. Don't worry, solve everything in degrees and then I will change it to radians. That is just by dividing the values by 180. You get it in terms of radians. 11 by 6, but don't forget to write pi. 11 by 6 pi. Even same over here, 210 divided by 180 would be 7 by 6 pi. That's how we can easily solve these problems. I know these are a little bit complicated, but practice many problems, you will be thorough with them. Now I will do this one as well. I'll do a few of these problems and then you will be used to it. Here we have 2 cos square theta plus 3 sine theta equals 3. Now look over here. This is not same as this. It's not cos and sine. It's not cos and cos or sine and sine. So what I would do is I would convert this to cos, because now it is very, very hard for me to solve because I can't take anything common out. I'll have to get this inside, right? And what will I take common out? Nothing. And it's not like 2 theta or anything. It's proper. It's cos square theta, sine theta. So here in this case, I will use the Pythagorean identity. I know sine square theta plus cos square theta equals 1. So you can just take the sine square to the other side. Subtract both the sides by sine square theta. Over here also sine square theta. This cancels. You're remaining with cos square theta equals 1 minus sine square theta. So it's going to be 2 times 1 minus sine square theta plus 3 sine theta. I'll take this 3 inside. Minus 3 is equal to 0. Now multiply this. 2 minus 2 sine square theta plus 3 sine theta minus 3 is equal to 0. And now we can simplify it. Minus 2 sine square theta plus 3 sine theta. Minus 2 plus minus 3 plus 2 is minus 1 is equal to 0. Now just like what we did in the last problem, we can write this in terms of x. It'll be in terms of x, not in terms of sine. So it'll be 3 minus 2x squared plus 3x minus 1 equals 0. Use your calculator to solve this quadratic equation. Here we have mod 5 and 3, minus 2 plus 3 and minus 1. The answers are 1 and positive half this time. So x is equal to 1 and x is equal to half. That means it's sine theta equals 1 and sine theta equals half. We just now did negative half. Now we can do positive half. See, 1, it's a good thing. There's only one value which reaches 1 in the sine graph for one cycle. So if you just do sine inverse 1, it's 90. Always remember, which are the values which don't have two of the answers are? It's 0, 90, 180 and 270. Whenever you have, say over here it's 0, 1, 0, minus 1. Sorry, 0 has two values. But you know, if it's 1 and minus 1 was sine, it's only one unique value. So you just write theta is equal to 90 degrees. That's it for 1. Because another one will be minus 1 for 270. You can try sine 270 is minus 1. Whereas for cos, it is different. It'll be 1, 0. It starts with 1, 0, minus 1, 0. It's different. Cos, it's like this. Okay. But anyways, whenever you see sine 1 or minus 1, you are only one theta answer. This is it. And what about over here? Again, use the calculator. It'll be sine inverse of half, 1 by 2. And we know it's 30. And just a while ago, we tried and we found out the another answer is 150. So I'll directly write the theta is 30 and 150 degrees. Don't forget, each of this must have plus 360 degrees K. This is very important. Now, I forgot to tell you one more thing. You need to check these answers as well. How do you check? Now, we got three answers. We cannot be 100% sure that all these three are correct because there's quadratics involved. Extraneous solutions might occur. So what is the easy method is, get all the trigonometric functions to one side. Here it's easy. Just take the left side and type it in the calculator. 2 cos square, cos instead of theta put x and this entire thing is squared, because cos square, that means I'll just put the brackets properly, it's the entire thing cos. Okay, the cos trigonometric function, cos x to the whole square. Cos square x is cos x the whole square, and then we will add a plus 3 sine x, that is over here sine alpha x. Now we will test the values. So instead of x now, let's substitute these values. I will calculate at 90. And the right side must be equal to whatever is the given equation. And yes, it is equal to 3. That's true. Now let's calculate for the next value 30. And here we are getting 3. Okay, this is also the correct answer. Let's calculate at 150. And let's check whether we are getting, yes, all the three are the correct answers. Now here also you have to check and see, and over here whatever we got, both the answers are correct itself. So that's it. So this checking is very important to eliminate the extraneous solutions, which might be the solution over here when we solve it, but may not be true to the equation. So this is important. So that's how we solve this problem. And you can see the solutions are given over here. 30, 150 and 90. Yes, those were the solutions we got. Similarly, please do try this as well. I will do this one because it is cos 2 theta. Now here, remember, we have sine squared, cos 2 theta and cos theta. Without some identities, we cannot go ahead. Now, which is the identity to use? For cos 2 theta, there are plenty of identities. Now, the first identity you might remember, cos 2 theta equals cos squared theta minus sine squared theta. Now, if I use this one, it's the most ideal. Why? Because minus and plus, this cancels off, and then you're remaining with cos. You can use the method which we just now did. So let's start this. sine square theta plus, instead of cos 2 theta, I'm going to write cos square theta minus sine square theta. That is equal to cos theta. Now, what do we do here? We cancel this out and we will have cos square theta. Bring this inside, minus cos theta equals 0. Now, you might be thinking, okay, why can't I just cos square theta equals cos theta? Why can't I just cancel the squares and I can write just cos theta equals 1? The thing is, over here, you just can't, it's trigonometric functions. If you cancel like this, you are gonna not get the correct answers. So this is like, when you take the square root, there'll be plus or minus. So you need to consider that and all. So this is a problem. So you will not get the correct answer. So avoid such methods. Try to do the proper method as possible. See, this is the proper one. Cos square theta minus cos theta equals 0. I will change this to x square minus x is equal to 0. Now let's use the calculator and solve it up. I have substituted the coefficients 1, minus 1, and there's no constant, so it's 0. The answers are 1 and 0. So the x values are 1 and 0. X is equal to 1 and x is equal to 0. So cos theta equals 1, cos theta equals 0. Now for cos inverse of 1, we have a single value, that is 0, because if you know the cos graph, it starts from 1, keeps going down and like this, and then comes up and then over here. So the important points over here are this point, this point, this point, this point, and then this is 360 degrees. So it starts with 0, 90, 180, 270, then 360, right? So when is cos theta equals 1? If you take cos inverse of 1, you will get 0 plus 360k. That's only one answer we have got over here. But what about the other 0? There are two zeros, isn't it? From unit circle also you can get this, or from the graph of cos. Or if you do it in the calculator, if you do cos inverse 0, you will get 90 degrees. For sure you're going to get this answer. This is true, but there is one more answer, that is 270 degrees as well. Don't forget this, plus 360k for both, plus 360k. Now these are the three solutions. It's 0 degree, 90 degrees, 270 degrees. Now we need to quickly do a check as well. So what I'll do is to check this, I'll get this cos theta inside. It'll be easier. It'll be sine square theta plus cos 2 theta minus cos theta equals 0. So type this particular equation in the calculator. That is sine square. So first write sine x, close the brackets properly, use the brackets and square it up. And then we have got plus cos 2 into x. You can just write 2 alpha x, that's fine. It's multiplication automatically. And then we have cos alpha x. Now this is the equation. Whatever we type, the answers must give us 0. Let's start with calculating at 0. Yes, we are getting 0. That's correct. Let's calculate at 90. We are again getting 0, and we should do at 270. It will be 0. So now these are the answers. Since they have not asked us to solve in radians or anything, you can just leave the answers like this. You can see here. Okay, here you can see the 0 degree is correct, but 90 degrees is also correct, but they have written 180. Why is that? Because we know cos graph for 90, it keeps on repeating, right? It keeps on repeating at 180 degrees, not at 360. But if you write like this, 90 degrees plus 360, 270 degrees plus 360, it's absolutely correct. But if you want to write only 90, because we know every time cos graph will be at 0 at 180 degree period, you can just do 180 into k. But if you you can stick to what I did, or you can stick to this. But please remember, if you're doing this, make sure you change the period. It's not 360 times k, it is 180 times k. So I would personally suggest you just go with this method, which I've done all the time. This is going to work. So this one, again, please do try solving this by yourselves, because this is again straightforward. You just take this to the other side, use quadratics, solve it, you'll get the answer. And the worked out solution is also available over here. You can check it out. Please do test as well, and you will get the correct answers. Now here we have a real life situation problem. Due to ocean tides, the depth y in meters of the River Thames in London varies as a sine function of x. The hour of the day on a certain day, that function was y equals 3 sine pi by 6 of x minus 4 plus 8, where x is 0, 1, 2, 3, 4. Okay, it keeps on going till 24, corresponding to 12 midnight, 1 a.m. Okay, so 0 means it's 12 midnight, 1 means 1 a.m., 2 a.m., 3 a.m., this x values. So if we get x of 5, it is 5 a.m. till the next night's 12 midnight. So 24 hours are mentioned. What is the maximum depth of the River Thames on that day? At what times does this maximum depth occur? Okay, this is interesting. Now, since it's a sine function, we need to see when it is maximum. Y can be maximum when the sine function is maximum, right? They want to find the maximum depth of the river. And it's varying based on sine function. When is sine function maximum? When is sine theta equals maximum? What is the value of maximum sine? It starts from 0, goes up like this. It's only maximum at 1. So 1 is the maximum. If you know the range, it's 1, minus 1, comma 1. This is max. So sine theta must be 1. So whatever is over here, it must be 1 basically. So the easier way would be, you can just directly do 3 into 1 plus 8. I think so. This is fine. You can just do it like this. So you can tell over here, you can just write, instead of putting sine 0, to tell sine function is maximum at 90 degrees. So you can substitute this as 90 degree and solve. But otherwise, you can just tell them y is equal to y is equal to 3 times 1, because this should be maximum in order to have the maximum depth, plus 8. And this will be 3 plus 8 is 11. So 11 must be the answer. Let's just check the answer for a minute. And yes, 11 meters. Over here it's given in meters. So we can just directly do this, and that's also fine. But you need to write in detail, because it's writing. You can use any methods and solve. Just make sure you write it and tell them, maximum function, sine function can be 1. And this is the reason why you can directly substitute it. Now for the part B, what time does the maximum depth occur? Here you must remember, we just now did sine theta equals 1, isn't it? So this x value you need to substitute, you need to solve. Basically, we know theta at the maximum depth must be equal to this, and then solve for x. In other words, if you know the sine graph, it starts from 0 like this, right? So over here, what is the theta value when sine theta is 1? It is 90 degrees. If you don't understand the graph, don't worry. Just do theta is equal to sine inverse 1. Why? Because we are dealing with the maximum depth, nothing else. So it is 1, sine inverse of 1. Theta will be equal to 90. This is how we get it in the calculator. I'll just show you. So you can press shift and sine and then put 1, and you will get 90. But here it is in pi. So what we will do is, for this problem, let's shift the mode to radian. Shift mode, and we will get radian. 90 degrees in pi is pi by 2. So we must get pi by 2 or half pi. So this made our job very easy. Why? Because now I can just tell this part, pi by 6 times x minus 4 must be equal to pi by 2 or half pi. Why? Because that time it's maximum. Now just solve it. Pi cancels. Take the 6 to the other side. X minus 4 is equal to 6 by 2. X minus 4 is equal to 3. 4 goes to the other side. It is x is equal to 3 plus 4. That is 7. So at x is equal to 7, it is maximum. So we can just see over here. It should be 7. Okay, now why is it 7 a.m. and 7 p.m.? Why is it? Why? Because now if you know the sine graph, it starts like this. It keeps on repeating, right? Now the maximum value at 7, it comes again. So here after 12 hours, again it will repeat itself. So it will be 7 a.m. and 7 p.m. This is the reason. So this is how we can easily solve it up. You can do the short methods as long as you have written everything properly. That's more than enough. You can directly solve it up. Now here we have few more problems. I will do this one because this looks a bit complicated, but it's not that. So what do we do over here? We have sine 2 theta, we have cos, we have sine. So whenever you have double angle identity, please use the identity and split it out. So we will write cos theta multiplied by sine 2 theta can be written as 2 sine theta cos theta minus 2 sine theta plus 2 is equal to 0. And now over here, multiply this cos theta inside. What's happened? These two are multiplication, right? It'll be 2 sine theta. There's no plus or minus, so don't do distributive property. This is one term, just multiply it. Cos and cos is repeated, so it'll be cos squared theta minus 2 sine theta plus 2 equals 0. Here, how we can simplify it further? I can see 2 is common. I can divide all the sides by 2, left side and the right side. 0 divided by anything will be 0 itself. So it'll be 2 will just go off. Sine theta cos squared theta minus sine theta plus 1 will remain equals 0. What I can do is I can take this 1 to the other side and just solve these trigonometric functions, because now I can't simplify anything further. So that plus 1 goes to the other side and becomes minus 1. Now here I can see sine and sine. Let me take the sine theta common outside. What remains? Cos squared theta minus 1 is equal to negative 1. And now we can equate this to negative 1 and this to negative 1 and solve it up. So sine theta equals minus 1. Cos squared theta minus 1 is equal to minus 1. And now let's see what is sine squared negative 1. This is going to be minus 90. Yeah, it is negative 90. You can just use a calculator and double check. Over here, theta is equal to negative 90. But I'll use the, over here, I'll simplify and then I'll show it in the calculator. Minus 1 goes to the other side, it becomes plus 1. So cos squared theta is equal to minus 1 plus 1 is 0. Right? Because this becomes minus 1 plus 1. And take square root on both these sides, it's going to be cos theta equals 0. Now you need to find when cos theta is 0. There are two answers in this case. Why? Cos theta. Yeah, cos inverse of 0. So theta will be, let's solve it up now. So we can do sine inverse of negative 1, that is minus 90. So that's one answer. And what about the, here, it'll be cos inverse of 0. One answer is 90, and I will show you. Cos 90 is 0, yes, but even cos 270 is also 0, isn't it? So we have two answers basically. Now that 270 degree is a common answer over here. What is the coterminal angle? Theta is equal to minus 90 plus 360. That is, theta is equal to 270 degrees. Here also we got it. 270 plus k into 360. And here we got two answers. Theta is 90 plus k into 360, or the same answer, or theta is equal to 270 degrees plus 360k. So you just write it once. So these are the two answers. Now they have told do it in radians. Now first of all, I have changed my calculator mode back to radian. I generally clear it every now and then. When you clear your calculator, it gets back to radian. If you're not getting the answers properly, check, sorry, it's in degrees over here, so check which mode it is. Now I have put my calculator back to degrees, so therefore I get everything in degrees. Now if I make it to radian, I'll get in radian. Now then we need to do the check as well, so I will quickly do the check. So I will take this 2 to the other side, it becomes minus 2, and this is gone for the checking of this problem. Here we have cos alpha x, close the bracket, and then we have sine 2 alpha x. So if you write it together, it's already understood it's a multiplication. Then we have minus 2 sine alpha x. And then I've taken the 2 to the other side. So I don't write numbers at this side. So let's calculate at 90. Let's start at 90. It must be minus 2. Yes, because 2 goes to the other side, it's minus 2. Let's calculate at 270. And look over here, it's not minus 2, it's positive 2. So that means this is extraneous solution. So the only answer over here would be 90 plus 360. Please keep this in mind. This is the correct answer, not these two, not the 270 degrees. So the answer must be only one here, and yes. And I forgot to tell you to convert back to radians, because I've clearly mentioned 90 means pi by 2 in terms of radian. And when you're writing in terms of radian, so pi by 2 plus 2 pi k, this is what we write, because 2 pi means it's 360 degrees and k is the integer. That's how we do it. Now here this is a simple problem but looks complicated. I'll just tell you how to do this quickly. Here, just consider sine theta equals x and simplify. It'll be 2x squared plus root 2 minus 1x, and bring this inside. Minus root 2 by 2 is equal to 0. Use your calculator to solve this quadratic equation. Substitute the coefficients 2. Now here, let's use the bracket. As it is, just type it out. See, now over here you need to be careful with the brackets and everything. It's root 2, close the bracket, minus 1. Now we had opened the bracket initially, I'll close that as well. If you want, you can avoid that first and last bracket because that's not necessary. So that is done. It will automatically compute it, and even over here. So we have root 2, close the bracket, divided by 2. But I forgot to write the minus sign, which will give me an error otherwise. I'll write minus root 2 divided by 2. That's the answer. It's negative 0.707. Now press equal to. The answer is half. And now we just now type this. This is also one same answer, okay? The answers, I just forgot the answers. X was 1 or half. Let me just double check it. It is half and negative root 2 by 2. X is half. And I'll write this. X is negative 0.7071. I know this is negative root 2 by 2 itself. But now I will tell you how you can, even if you write this, you can get the correct answer itself. This is all sine theta, okay? So sine theta equals half, and here sine theta equals negative root 2 by 2. Now how do you find the theta value? Just take the inverse. Go to computation mode and press shift and sine 0.5. We know this is not the only answer. There is one more answer. Yes, theta is 30 degrees, but at the initially first problem we had seen, it is also 150 when it is half. Now what about this? Here, if I put sine inverse, let me take the decimal, minus 0.7071. What is the answer you're getting? You're getting negative 44.999, which is almost negative 45 degrees, right? But if you put the exact value, that is root 2 divided by 2, you will get the exact answer of negative 45 degrees. But otherwise also, it shows you it's almost 45, okay? So this is theta negative 45 degrees. Now everything is plus 2 pi k. We need to convert it to radians as well. I'll tell you in a minute about that. But over here, what is the other answer? Now, since it is 45, it is very, very easy. CAST, cast diagram. Now, we want negative root 2 by 2. We know it is negative 45. That means the answer over here is negative 45. That means it is at this point over here. Okay. So that will be middle of 270 and 360. You should just add 270 plus 45. I'll just do it over here directly. 270, this is 360. If you just add 360 here, you get the coterminal angle. So it will be 315 degrees. So this one, 315, is exactly in the middle of this. Because I know it is sine negative root 2, it can't be this and this. Why? It can't be 45 degrees because I'll have positive root 2 by 2 over here. I'll have positive root 2 by 2 because sine is positive over here both. So it must be this one, 180 plus 45, that will be 225 degrees. So these are the solutions, this 225 and 315. So theta is 315 and also 225 degrees. Now we need to convert this to radians. How do we do that? Take any angle, just divide by 180, and in terms of pi we need to write 1 by 6 pi. So that will be the answers over here. You can see it's pi by 6 is same as that. 150 is basically 5 pi by 6. I can show you it is just 150 divided by 180, and that is the answer. That is 5 by 6. And over here we have 225. 225 divided by 180 is 5 by 4 pi. And lastly we have 315, that is 7 by 4 pi. And now if you have checked, you need to check it over here. You won't have any extraneous solution because of all of these solutions. Let us do the check as well. I'll just erase this. To check, you need to type this as it is. 2 sine alpha x, open the bracket for sine, and again close it up, square it up, plus, now here it is root 2 minus 1, root 2 and minus 1, close the bracket, and I'll put sine alpha x. Now it'll take a long time if the check is in terms of pi, so I will just use degrees. I'll do shift, it's already in degrees, so it's fine. So I'll just do calc at 30 degrees. I must have this right side as the answer. Yes, it is correct. I'll do calc 150. Yes, it is again correct. Calc 225. I'm getting the same answer. And lastly, calc 315. And over here, all the 4 answers are the correct solutions. So this is how we solve it up. Now please do solve this by yourselves. Over here we have done similar problems. Just substitute the values, split it out, and then solve it up. Here these are the answers, and over here also we get the answers. Now if you're thinking how to solve this, don't go to do any identities. You can easily split this out. So this part is cos squared theta. Now then you can easily solve it. Cos squared theta minus cos theta. Bring this inside minus 3/4. And find the values and then check the values. Here also they are pretty simple. We just now did them. Solve it by yourselves and then check the answers. We did similar problems. Please make sure to check that the extraneous solutions are found. If there is a wrong solution, don't add it in the final solution. Do the check and then you can just mark extraneous solution and the proper solutions. Question 18 is to find determinants and inverses of matrices. It is from lesson 5.2. Here we have got 2 matrices. You can see it's matrix A and B. They both are 2 rows, 2 columns. Now we need to find whether they are inverse of each other. There are different methods. Exactly, they have not specified which method to use or anything. So one method would be finding the inverse of this matrix using formulas, and if you get this, yes, that is true, otherwise no. I'll do that method, but the first method, the basic method, is multiplying them both. You multiply AB, and if the answer is I, identity matrix, and also if you multiply B and A, then you get I, then yes, it's inverse of each other. Now how do we multiply? See, multiplying matrices, it's easier if you have them together side by side. It's 12 minus 5 minus 7, 3 over here, and this is 3, 7, 5, 12. Now what you do is the first row with the first column. So 12 times 3 plus, this is the tail, head and head, minus 7 times 5. That's the first newly formed digit of the matrix. And next one, the same row with the second column. It'll be 12 times, leave some space, 12 times 7 plus minus 7 times 12, and then the below row with the column, first column, it'll be minus 5 times 3 plus 3 times 5. And lastly, we have got minus 5 times the last second row, that is minus 5 times 7 plus 3 times 12. This is it. Now you can just put this in the calculator and solve it up. Let's see over here. 12 times 3 is 36. 7 times 5 is 35. So, sorry, 7 times 5, yeah, 35. Minus 35. So here we have got 36 minus 35. And here we have 12 times 7, that is 12 times 7 and 7 times 12. And minus is there, so it becomes 0. They cancel off. It is 84, 84. 84 minus 84, 0. Over here, 36 minus 35, I'll directly write it. It's 1. Here this is 1. And what about this one? Same thing, it cancels off. Same number, 0. And over here you got 7 times 5 is 35. And see, minus 35 and positive 36 will be positive 1. So yes, we got the same thing. This has to be multiplied, A multiplied by B. So AB will be equal to I. Now the same thing needs to be done to B and A. Now here this was the first step. Step 1, find AB. And we did. This is A, this is B, and we multiplied and we solved. It is identity matrix. It is equal to I. This is equal to I. That is 1, 0, 0, 1. Now you need to do B and A. Step 2, it'll be find BA. B and A. So B will be second matrix over here. Matrix B is 3, 7, 5, and 12. And then we have A, that is 12 minus 7 minus 5 and 3. So now let's take this with this. Here we have 3 times 12 plus 7 times minus 5. Then the second one will be 3 times minus 7 plus 7 times 3. Then we have 5 times 12 minus 12, sorry, it's plus 12 times minus 5. And lastly, we have got 5 times minus 7 plus 12 times 3. Let's see, this 12 times 3 is 36. 35, again, it's 1. Cancels, same terms, 0, 0. And minus 35 plus 36 is 1. So again, we got I. This is I. So this was by multiplying B and A. So BA equals I. Now what you can say is, because AB equals to BA equals to I, they are inverse of each other. They are inverse matrices or inverse matrices. You can write it from the question itself. So this is the thing, inverse matrices. So this is how we solve it. Now when they are inverses, when you multiply them, you should get identity matrix. That's the main concept. Now this is absolutely fine. Now you can do any other method as well, as long as you know whether they are inverse of each other. That is it, right? So what I'll do is I'll do another method. Now this method is important because inverse is generally found by this method. And even if two matrices are given, absolutely you can find it. And now here what happens is step 1. Find determinant of matrix A. Find the determinant, just this much, determinant. Now we know this is inverse, so what happens is I'll try to find the inverse over here by the formula, and whatever I get must be the matrix B. If I don't get, then it's not inverse. So find the determinant. How do I find the determinant? The formula is, now here if you have A equals A, B, C and D, then determinant A would be, or you can write magnitude, it's the same thing. Determinant can be also written as like this. This is called determinant A, will be equal to A times D minus BC or CB. It's the same thing. Yeah, this is the formula. Now let's find. Determinant A will be equal to 12 times, let's multiply these two. 12 times 3 minus, don't forget the sign minus. It is minus 5 times minus 7, or minus 7 times minus 5. It's the same thing. So over here we will have 35. Over here it is 36. 36 minus positive 35. The answer is 1. Determinant is 1. Therefore, inverse exists. You just write this. What does this mean? Look, when we find the determinant of any matrix, if we get this of when we do the determinant, we get 0, then there is no inverse. It cannot be possible. When you get any other value like a negative 5, negative number, positive number, any number other than 0, there is inverse. So therefore, we tell this 3 dots means it's therefore, or you can just write hence. Or even if you don't write, it's fine. You just continue to find the inverse. That's it. But if it was 0, then you stop. You tell there is no inverse. Why? Because you cannot find the inverse, because over here there is 0. So this is the step 1. I hope this is clear. You can pause the video, write it down if you want, because I'll move to the step 2 now. I'll clear this off. Please remember it's 1. Keep it in mind, but you can see it, refer it later. The step 2 is to find the inverse. Find the inverse. Which inverse are we finding? It is the same matrix. It is of matrix A itself, because we found the determinant of A. The formula is given here. If we have A, B, C, the same condition. If you had A, B, C, the inverse, A inverse is, see the symbol, A raised to negative 1, that's the inverse symbol, would be here the swap. D, A. Instead of A and D, they swap out. And what about the B? It just becomes negative, and the C as well negative. Okay, I forgot to write the determinant. It's all divided by or multiplied by 1 by determinant A, or divided by determinant A. So this is basically the inverse. This is the formula. Now we know determinant A was 1, right? So here 1 by 1 will be equal to, what happens? It'll be 3, 12, minus becomes plus 7, plus 5. That's the answer. Now multiply this 1 by 1. Anything you multiply, it's the same thing. So the answer will be 3, 7, 5, 12. This should be the inverse. Let's just check it with B. Yes, absolutely, it's the same thing. So this is A inverse. Now what you can say is, hence A and B are inverse matrices. Inverse matrices. So now even if you write these 2 steps and solve it like this, it should give you full marks. Just make sure you let your teacher know if they are okay with this method, because absolutely this must be okay, because any method you do, as long as you tell these are inverses, it's true. Why you can tell? Because A inverse is 3753, right? Now if I find the inverse of this, I'm going to get back A itself. Now no need of doing AB, ABA, because the multiplication at times tends students to do simple errors. A sign might miss or something like that. So this is a confirmed way. Here, matrices can be easily solved in calculator as well, but I'm not going to tell any calculator method here because it's the writing part. But for the electronic part, all the matrices, I will show you the calculator method, and I will solve it by calculator method itself. So we'll move on to the next problem. So they are inverse of each other. All these are the same thing. Now we have plenty of same type of problems. All you can do is multiply these both, or you can find the matrix of A, and if it matches, yes, that's your answer. So here we go. Here they are inverse because both the time you got identity matrix, or if you quickly find the determinant and solve it up, you must get each other. So here, let me just find the determinant first. 3 times 4 is, see, now I'm not going to write in steps. Whatever I wrote for the first problem, please maintain that. Write it in steps, everything in detail. So when you're solving these problems by yourself, write it accordingly. But now over here, I'll just write it very quickly. It'll be minus 5 times minus 4 minus 6 times 3. It'll be 20 minus 18. So it's 2. Inverse exists. So let's see whether the inverse is true or no. It's a 1 by 2. And here we have minus 4, minus 3, minus 6, and minus 5. Absolutely no. This is not the right one. It is, yeah, when you multiply half, it's going to be minus 2, minus 3 by 2 or 1.5, minus 3, and minus 2.5. They don't match. So this has an inverse. The matrix A has an inverse, but it just doesn't match with the given matrix. So here they're not inverses. Now even if you do this method multiplying, you will get some other answers. So they are not inverse. Here as well, it's the same method. You can quickly do it by yourself and then check. You can also use the below term. Now, for example, this one, you can find inverse of B. And if it is A, then yes, otherwise no. So first let me find determinant of B. The two lines modulus means it's determinant. So it's going to be minus and minus plus 9 minus 10. That is minus 1. So here 1 by minus 1. And what are the terms? We have to swap these two, minus 9, minus 1. And over here it'll become minus 2, minus 5. See, here it's, don't think it's wrong. Okay, I did a mistake. These two swap, and yeah, now it's all right. Now this is absolutely, don't think, okay, we are not getting the sign. But remember, there's minus 1 outside. When you multiply it, it's going to be 9, 2, 5, and 1. So yes, this is the inverse itself, 9, 2, 5, and 1. I hope this is clear. So they are inverse of each other. If you multiply, you'll get I. Now, similarly, please solve this problem over here. You will be stopped at the beginning itself because over here they are not inverse of each other. You're not getting identity matrix, therefore they are not inverse. Over here they are inverses, and over here they aren't. Now, remember, there might be a situation where when you find determinant A would be equal to 0. And in such case also there is no inverse. It's not only that you'll get some inverse and it doesn't match with B. No, it's not only that situation. Even when you have a determinant of 0, that's not the inverse of each other. Now these type of problems we have to do in the method which I just showed you. Let me solve this problem here. So step 1, find the determinant. And what you need to do is to find determinant of A. I'm not going to write the formula. I'm directly solving it up. Minus 4 times 3. But in the exam, better to write the formula. Write a matrix A with ABC, ABCD, and then write the formula. It is A times D minus BC. So minus 4 times 3. Minus 6 times 2. And now minus 12. And this is minus 12, but you add it up with it plus 12. So the determinant is 0. There cannot be inverse. This is a singular matrix. When there is no inverse, we call it singular. When inverse doesn't exist means when you get a 0 at your determinant. Because this is 0, we can tell it is a singular. See, this is the answer. Here they have done row transformations. It's absolutely fine. You can do this, but row transformation just takes time, and many of the times students might tend to choose these numbers wrongly, and then it's just confusing. So what I would suggest you is stick to this method, and this also gives you the correct answer. It doesn't matter which method you use, as long as you do in writing correctly, it's fine. Now here, that's the row transformation. Same thing here. Let's try this one. It'll be determinant A will be equal to 4 times, it'll be 8 positive minus 8. Now again, this is singular, it's 0, matrix is 0, so it's singular. I hope this is not singular. I don't think so. This is singular. So it's 5 times 3 minus 9 minus, and again we have minus 10. Now when you add it up, minus 9 plus 1 plus 10 is equal to 1. So this is how we found the determinant. Now all you do is swap these up. 1 by 1 multiplied by minus 3, 3 minus 5, 2. Because when you multiply minus with minus, it becomes plus. So the final answer would be 3 minus 5, 2, and 3. So this is how we solve this matrix. I hope this is clear, the inverse of this matrix. Pretty simple. Okay, did I miss something? What did I miss? Okay, I'm just very tired and sleepy. Maybe that's the reason I missed it. It's minus 5, minus 3, 2, and 3. Yes, it's minus 5, minus 3, minus 5, 2, and 3. Here they are doing the check or the verification by multiplying a with a inverse, which we just now found, and you must get I. Yes, of course you'll get I. And similarly, you're doing it with a inverse and a. Now you don't need to do this check as long as you write this properly and find the, so not this part, you find what is the inverse. Just find the determinant. If determinant is not 0, you will find the inverse. Look, it's better to stick to this method with the formula, because this method is useful even later on. Now here also the same thing. First you need to find the determinant and then use the inverse formula. So you can see here, and you will get some answer. So these both are, this is having inverse as well. Which is the inverse? That's over here. So 2 minus 5 by 2 minus 3 and 4. Even you can do it quickly here. Let's do this quickly. 8 4s are 32 minus 6 5s are 30. So the answer is 2, determinant. And then we just swap it out. 4, 8, minus 5, minus 6. But what do we have to do is 1 by 2. So half of everything. So it's going to be 2 minus 5 by 2, or 2.5. And here minus 3, and lastly we have 4. So that is the answer. And let's just check we got the same thing. Yes, it's 2 minus 5 by 2 minus 3 and 4. You can easily do this, but if you're going to do this method, it takes a long time because you need to do transformation of each and everything. So I would suggest you to stick with the formula method. We have 3 cross 3 matrix here. For 3 cross 3, I will tell you how to do a determinant, the determinant easily in a different method. And then for the inverse, you can just use your calculator. Because otherwise, the row transformation, I'll just show you, it just takes such a long time. You can see here. And I'm sure it'll just take most of your time in the exam. You know, you won't be able to do any other problem. All this just for that. And then if you verify it, it's gonna, take such a long time. What I would do is, you solve it in writing, the determinant, and then inverse, you just use calculator. Most of the time, almost always, these 3 cross 3 won't come for your exams. 3 cross 3 is generally not asked. So you can just ask your teacher beforehand, tell them the determinant, you will do it manually, but the inverse, as in the textbook, it is clearly showed that use graphing calculator. So we'll use the calculator method only for the inverse. Now here, the determinant in your textbook, it is a little different. You have to take this first term, then find the determinant of the remaining terms, these two, then this term, and ignore those and the remaining determinants and all that. It's very lengthy. So there is an easier method. Write the matrix, minus 1, 3, 2, minus 1, 6, 1. And then we have minus 3, 4, 8. I've written only the 3 columns. You need to repeat these columns. The first column here, again I'll repeat it. First and second only, not the last one. So again, you're writing minus 1, 3, 2, and lastly minus 1, 6, and 1. Now here, let me just change the color. Let me take this one over here. First, you start with upside. To draw a diagonal line like this, slanting line. First row and first column, and then over here the second row and the second column, and the third row and third column. These 3 are together, and the same thing over here, these 3, and lastly these 3. What do? You start with up to down. First up to down, Now, if you go down to up, the answer will be wrong. It will be opposite sign. It's from up to down. Now, let me write it. It will become minus 1. You multiply all these. Minus 1 times 6 times 8 plus minus 1 times 4 times 2 plus minus 3 times 3 times 1. That's the thing. Next, let me just change the color over here. This whole thing is subtracted with, let me consider here, from the down to up. So this was up to down, this one. So these three now rows, sorry, I mean these three lines. I hope this is clear. It's now minus, I'll put a bracket because minus will be multiplied, 2 times 6 times minus 3 plus 1 times 4 times minus 1 plus we have 8 times 3 times minus 1. These are the answers. Next, you just put them in the calculator. You can solve it up or you can do it one by one. It's up to you. So here what I'm going to do is 8 times 4, it is 48, minus, it's minus 48. Then plus, over here it's minus, so it'll be minus 8. Minus 3 times 3 is 9. Subtract the entire thing by this. 6 times minus 3 will be 3 times 2, 6, 36. But it's minus 36. Plus, again there's minus 4 and this is minus 1. So minus 8 times 3 is 30, 20, 24. And here it's going to be 48 and 8, 56, 56, 60, 48 for 65. Yeah, minus 65. Subtracted with 36, 40, 60, 64, minus 64. Now what you do is you have to do this minus minus. It'll be minus 65 plus 64. The answer is negative 1 here. The determinant, so you can write determinant of A is equal to minus 1. This is the step 1. Find the determinant. Find determinant, right? Now next one. After this, you should just write it down all along. And then clearing this, you write step 2. After this entire thing, you write step 2, find inverse. So now the formula, it's just a very, very crazy formula. So we're not going to use the formula. We'll just directly use the calculator. I'll even show you to check the determinant and the inverse in the calculator now. First thing is mode. In this mode, you can see matrix is at option 6. Press 6 and fill in the first matrix. That's option 1. And what is it? It was 3 cross 3 matrix. You can see the first 3 columns over here. It's 3 cross 3, it's 1. Now type in the values. It's minus 1. Then when you press equal to, it goes to the, so minus 1 equal to, it goes to the next column, the digit over here. That is going to be minus 1 again. And then we have minus 3. The first row is done. Now you go to the second row. It's 3, 6, 4 and 2, 1, 8. Okay, so now press AC. That's saved. Now please don't go back to mode anymore. If you go to mode and 6 again, that will be an error. You won't, the matrix will be unsaved. Now it's saved. You should just press shift and 4 anymore if you want anything with matrices. Now here the determinant is given by option 7. Press shift and 4 again for matrix A, close the bracket, and look what's the answer. It's minus 1. Yes, absolutely. How do you find the inverse? It's just by shift 4, type in the matrix which you want to find its inverse, and inverse symbol is over here. That's the answer. So here next what you do is you just write this answer out over here. You found the determinant, write the answer. That's enough. So let's just look at the inverse. Where did we get it? Here one. Minus 44, minus 5, minus 14, 16, 2, 5, and 9, 1, 3. Absolutely the same thing. So this is how you can find the inverse of 3 cross 3 because it's very huge. And if you do it manually, you won't get time. So do this method. Determinant is very important, this determinant part. Okay, this is simple. up to down minus down to up. But it's just that you should copy these first two columns again after the third column. See, it's 1, 2, 3. Again, it starts with 1 and 2. And then you solve it up. So this is the answer here. I hope this is all clear. Let's do one more. Let's find the determinant of this one. Again, first write 4 minus 2, 6, 2, 3 minus 1, 1, 5 minus 4. You get again 4 minus 2, 6, and 2, 3 minus 1. So not down to up, it's up to down. 4 times 3 times minus 4 plus. You can directly write over here the multiplied answer instead of writing all the terms. 5 times 2 is 10, 10 times 6 is 60. So we will directly write 60 plus 2 times minus, oh yeah, it's 2 only, but minus and minus will be plus 2. Minus, what's the values here? Down to up. So always you start with up to down. Come from here to down, then down to up. 6 times 3 is 18 plus, but there's minus, so I'll write minus 20. Then we have plus 8, 16. So here 16 times 3, 32, 48. It's minus 48 plus 62. Minus over here it's 20. Okay, there is minus and plus, so it's going to be 20, 34, 14. Positive 14. And what's going to happen over here? That's going to be 62. So it's 10, 12, 14 as well. Oh, I think so it's going to be 0. So it's 14 minus 14, it's 0. This means this doesn't, it's singular. So it's for such problems, when you find the determinant at 0, you write this is singular. Why? Because this cannot be transformed. Okay, now you can see the answer. There is no answer here. Whatever you do, your answer won't be. So you can see that there's no way you can get an identity matrix over here. There's no way it can be formed by, you can get 1, 0, 0, 0, 1, 0 and 0, 0, 1. So therefore you tell this is singular. Singular is very important. Similarly, please do try these problems by yourselves. You can see here, again the row transformation is done. It's again singular. If you do the determinant, it will be 0. You can check in calculator as well. So here now, okay, this has the answer. This is the answer. Sorry, I had to see the previous one. See over here, left side, when you transform it to identity matrix, whatever is the right side is the answer. Okay, so that is the inverse matrix. Left side, you have to get 1, 1, 1, 0, 0, 0, 0. In the previous one, whenever it is singular, you can see there's no way you can get it into identity matrix. It's just not possible. How much ever you try, one of the rows will be all 0. That means if you go ahead, there's no point. And so this is then confirming. You just multiply those both matrices and you will get identity matrix. Now we are back to the normal ones. Again, I'll do this problem quickly, not in steps, but when you're doing in your exam, you have to do the steps. So determinant A will be equal to minus 12. 6 times minus 2 is minus 12, minus and minus 15 again. So it'll be minus 12 plus 15, that is 3. Your determinant is 3, so the inverse will be 1 by 3. The swaps minus 2, 6, 5 and minus 3. So the answer is minus 2 by thirds minus, it's positive 5 by thirds, minus 1 and 2. Why? Because you multiply here, minus 2 by thirds, 5 by thirds, minus 3 divided by 3 is minus 1 and 6 divided by 3 is 2. So that's the answer. Here you go, that will be the answer. Be careful with the signs, and please, oh yeah, you can see that's the exact method which we do. This is the formula, this is the determinant. Both needs to be done, and that's it. If the determinant was 0, it's singular. You don't have an inverse. And this is the, see, you don't need to do this multiplication, because in this method, when you use the formula, that's it. In this, we already tell when it is determinant, when it's not having a determinant, there is a matrix. So that is it. Okay, if you want confirmation, just do it in the calculator, and you can tell using the calculator also you got the same answer, but you can just stop it over here. This is unnecessary. Please try these by yourselves. It's the same method again. Here you go. The answers are already there. You can pause it and check through the answers. And okay, now we have another interesting problem. We have to find the area of each of these triangles with vertices x1, y1, x2, y2, x3, y3 by using, see, area by this formula, half of determinant, this region. See, whenever you have coordinates, you can write X matrix where all the last ones, last coordinate 1, 1, 1, but this is x1, y1, x2, y2. It's up to you to choose. Choose this x1, y1, x2, y2, x3, y3. Or you can even change it, doesn't matter, you'll get the same answer. Okay, I just randomly chose here because 1, 1 is simple, that's why. But you can even choose this as x1, y1, x2, y2, x3, y3. You will get the same answer. What happens is, first you need to find the determinant of this matrix. The matrix will be, so now 1, 1, 1, 4, 3, 1, and 4, minus 1, 1. And we need to repeat it again, 1, 4, 4, 1, 3, minus 1. And now up to down first, to down. Here it will be 3 plus 4 minus 4. This entire thing is subtracted with down to up. 3 is a 12 minus 1 plus 4. So these and over here. And now then 3 plus 4 is 7, minus 4 is again 3, minus, here we have 3 and we add it up, it will be 15, minus 15. The answer will be minus 12. Let me just double check this. It's 3. Okay, one more thing. When you're writing these two columns, make sure it's this column in the fourth place and the second one in the fifth place. That must be, it must be the same thing. If you just rearrange even a single digit, your answer will be entirely wrong. 4 times, okay, we start with up to down. It's 3 only, 4 minus 4, done. Minus of 4 times 3 is 12, minus 1, positive 4. Okay, that is the answer. Now then, you got the determinant to be minus 12. Here, can you see this magnitude? Now, after this, this is your step 1. Find, step 1, find determinant x. Okay, we just found it. That is determinant x is equal to minus 12. Step 2 would be, I'll just write it out over here. Apply the formula. Apply area formula. Now what happens here is A is equal to half, write the formula, magnitude of determinant x, not A. So here it will be half of magnitude of what? Minus 12. Magnitude means whatever is the sign, minus or plus, just takes the positive value. Because determinant can be negative or positive, right? But area will be positive itself. So this is positive. Half times 12, that is 6 is the answer. It should be 6, the area over here. So you can see, writing this determinant first like this, and then what we do is, now this is the determinant long method. You take the first term, write this formula. It's just too lengthy and it takes more time, and there are chances you will make a simple mistake anywhere over here because it's plus, minus, plus. This one over here, whereas it's very easy, up to down, minus, down to up. That's it. If you just remember that, it's very, very easy. Then once you find the determinant, it was minus 12. Then you put it in the formula, it will be positive 6, which is the same thing what we got. That's the answer. Again, there's another problem. Guys, you can try this by yourself because it's just same thing. You just apply over here 1, 6, 6, 4 and 2, 0 and you solve it up. The way you can see this, the long determinant method or the short one, which I'm telling you, it's the same thing. Here you first write it out. You can even interchange this. You can write 2, 0 first, 1, 6 down. It will be the same answer. And then after finding the determinant, you use the formula. Its determinant is minus 28. You can check in calculator as well. Then it will be half of that, 14. Remember, this area formula is given. You have to use the exact same one. Not determinant is not the answer. Area over here needs to be found by half times whatever is the determinant. And here as well, I'll just do the next problem, the last one. Same thing, it's 13.5. And let's do this. First, step 1, determinant x. Let's bracket. Now what we do is we write x1 7 3 1, 6 minus 1 1, and lastly 1 minus 3 1. And this repeats 7 6 1 and 3 minus 1 minus 3. Now it's always from upside to downside. Minus 7 plus 3 minus 18 subtracted by minus 1. 7 times 3 is 21, it's negative 21, and plus 18. Next, what we do is we add them up over here. It will be minus 4 minus 22, and here we have minus 22 plus 18, that's 4. Let me just double check it. 18 minus 2, it's minus 4. Minus minus will be plus, so it will be minus 18. And now step 2 is area. Area is half times, you should write the formula and everything, minus 18. So it will be half times 18, that is 9. 9 units square is the area. Let's check the answer. Here you go. You have to do the determinant, and it was 18, but subtract negative 18, and then you use determinant, so it becomes positive 18, and solve it up. Half times 18 is 9, and that is the same answer which we got as well. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. Question 19 is about writing and graphing parabolic equations. It's from lesson 6.1. Before we begin, we will look into a few crucial formulas. Now let me explain these things with first the upwards or downwards, that's vertical, okay? Or this is vertical, next one is horizontal. Here a few important things. The vertex is the bottommost or the topmost point, and then there'll be focus. Focus will be inside the parabola, always inside. Okay, this will be outside, this is inside somewhere over here, over here. And directrix will be outside the parabola. If it's opening upwards, it'll be like this down here somewhere. Now for this one, here it will be at somewhere over here. It varies. Now, you can see this is basic things of a parabola. Now you can see here in the vertex and focus, the x-axis is always the same. So if you look at this one, when y is equal to x is given, it's either opening upwards or downwards, it's vertically aligned. Now here you can see h and h of the focus and vertex must be same. Whereas the k, if this vertex is given, x and y value will be h and k. Whereas this one is inside, so it is added with some value. That is the lattice rectum is added. The 1 by 4 times a, sorry. So k will vary, you need to add. Even over here, you add it up. Okay, it's the same formula basically. But directrix is outside, so we subtract. To the k value, we subtract it. That's how we get the formula. So that's the basic understanding. You can even, just remember when y is there, y equals to, it's vertically, moving up and down. So the y, that's k and k will be different. And over here for directrix, it's minus 1 by 4a. For focus, it'll be 1 plus 4a. Now, what if it opens left or right? Here is the focus, this will be the vertex. If this is the vertex, this is the focus. Now here what you need to remember, very important, is it's not the x-axis. See, x-axis, sorry, over here it was the y-axis that was varying, right? Here y-axis remains same. Imagine this is 0 and this is 3. Y-axis is the same for vertex and the focus. So you can see the k value will remain the same. K is the y, right? X and y. K value is remaining same for the vertex and the focus. Whereas the x-axis over here, x, because it's inside, you add it up. See, it's plus h plus 1 by 4a. Over here it was k plus 1 by 4a. But directrix is outside. If this is the vertex, directrix can be somewhere over here. For this, will be somewhere over here outside the parabola. So it'll always be minus. I hope that's okay with the formulas. Now we will look into the problems. Here they have given us vertex, focus. Step 1, write what is given. This is very important. Given. Here vertex, that is h comma k, is given to be 0 comma 1. What is focus? Now here I'll write focus is 0 comma 4. Now look at this. What is the same? X-axis is same. Only y is changing. If y is changing, then the formula we use, what is changing here? Y equals a of x minus h the whole square plus k. So this is the formula. Now if you go back here, let me just show you. See, whenever y changes, the standard equation is y is equal to a x minus h the whole square plus k. Whereas if x is changing, it will be x is equal to. But here remember, it will be a into y because x is already written outside. It's y minus y is along h and k. K is y axis. So it's minus k the whole square plus h. So this is the formula we'll use for this particular problem. And what is the formula for focus? H is same because you know same thing. K will be added by 1 by 4a. And we need to get this. Step 2 is equation. Okay. Step 2 is the equation. We know y, it'll be the same thing. A is unknown. What is x? X is same thing, but h is given over here 0. So we know h is equal to 0, k is equal to 1. So minus 0 the whole square plus 1. Only thing that's missing here is a value. So it's almost done. It's x minus 0. So it's x squared plus 1. But what is the a value? How can we solve it? We have a relation here. K plus 1 by h. We know the k value is 1. And the focus is over here 4. This part. So I can write k plus 1 by 4a, that is this part of focus that's given as 4, right? What is k value? It's 1 plus 1 by 4a, that is equal to 4. See, you've substituted. You can just put this entirely in the calculator and get the answer. I'll show you. All I will do is I'll write this as an equation. 1 plus 1 divided by 4 times a is a variable, unknown variable, so I'll write alpha x. That will be equal to 4. You can shift and solve and press equal to. The answer over here is, see, 0.083333. Now, if you want, you can write this because it's the writing exam. Technically, it is correct, even if you write 0.83333. Generally, in your answers, we write it in terms of fractions. So how can we get this as fraction? It's 0.083333, right? Press on. Now, x value is stored as the answer. Type equal to. Over here, you can see it'll give us the fraction. So, but over there, when we press shift and equal to, it will not give us the fraction. But now when I type it equal to, it's the fraction 1 by 12. So, a is 1 by 12, or you can write it as a equals, it's up to you, 0.833 dot dot. It's better to write 1 by 12. But now if you are thinking of the steps, it's simple as well. It's 1 by 4a equals, this goes to the other side. It'll be 4 minus 1, that's 3. I need a, so I'll take a over here. It'll be 1 by 4 times 3 equals a. That is, a will be equal to 1 by 12. Up to you. You can avoid these steps. Directly jump over here from the calculator. It's fine. You've substituted everything, and from the calculator you get this answer. So now I know the equation is a is 1 by 12. So here I forgot to mention, this is step 2. Step 2 is finding a value. Step 3 would be writing the equation. Okay. Then what I prefer is I need to write this equation in this at the beginning itself. Leave some space, write it up so I can understand this. The last step, I like to write it as second step. Why? Because now it gives me a clear picture what's missing. Then I do this and then I complete this again. So that's how I do it. Now it's not over. We have to graph this. Let's just check the answer. It should be 1 by 12 x squared plus 1. And over here you can see the given, all the details. See, now they have used a different method as well. They've just substituted everything and tried to solve. Here only this A is missing. Yeah, whatever is given, you substitute. What is missing? A, and you find the A value. That's the formula you use. And yeah, that's the correct answer. The same answer which we got. But it's better to write these steps. Step 1, 2, 3. Now we have to do the graphing. See here, to graph, vertex is given, focus is given. You can find the directrix, but there are plenty of ways to graph. Let me just look at the graph here and tell you. You know the vertex is 0, 1, right? So x is 0, y is 1. This is the vertex point. Now the graphs will go here depending on the a value and everything. So how would you get these points? There are ways. From focus you can get 0, 4, and then you can try and do it. But I would suggest you to go with the table method because it's very easy and it can be used to graph any equation. Okay, all the equations are possible. Let's take a table and do the table method. For graphing using table method, we have to get this equation. Now mode, go to 7, table. And here it's 1 divided by 12 x squared plus 1. No matter what, you will be solving this equation. So just type it out over there. And then you may not get this option. Even if you get this option, just press equal to. Now where do you start? Where is the vertex? It's 0, 1, right? So x value is 0. Take some values before and after this. So I'll take about 3 values before this. Okay, I'll take -3 and let me take +3. And here we go. This is the table. You can see if you want the fraction form, it's over here. It's up to you to use whichever form you want. Write this out. Make a table, simple table. X, Y. It's -3, -2, -1, 0, 1, 2, 3, right? Look at the values here. It's 1.75, 1.333, 1.083. And over here, if it's 0, it's 1. And get all the values. And then you can see they'll be symmetrical. Why? Because after vertex it repeats, right? So these must be the same here. It's again 1.083, 1.333, and 1.75. Now let's plot them up. 0 is 1. What about -1? It's little more than that. See, it's just little. Over here, accordingly. No need to be very accurate. Just a rough sketch is enough, and just join those points. And there you go. That is the graphing. So if they have asked you to graph, they will give you this graph, coordinate graph. So just make sure you take an appropriate scale. Over here, 1, 2, 3. 1, 2, 3 is just taken, and then you graph it up. So that's how we can graph it. The table is easily obtained from the calculator. So there we go. That is the answer. Another problem. Let me solve this as well, because over here the directrix is given and no focus is there. I'll not write all details. Step 1, just refer to the first problem for the more details. Over here, I know h, k is equal to 1, 8, and we have directrix y is equal to 3. What is this directrix exactly? Here, if y is equal to 3, y over here is 3. It's a straight line over there. If it's on the y-axis, then what is the equation? You can just remember, if it's like this, the equation must be y is equal to ax minus h the whole square plus k. Let me explain. If we have a horizontal line, the opening can either be upwards or downwards. There's no other way. Okay, it has to be, because if it's a vertical line, then the parabola can be either like this or like this. There's no other way. So this is why we can easily tell, okay, this is a horizontal line. It should be vertically up, or it should open upwards or downwards. But if you want to know where it opens, over here you have vertex. X is 1 and 8, somewhere over here. So that is the vertex. So it is opening something like that. Okay, you don't need to understand where it's opening, because we will solve it anyways. We'll get the equation and then we'll graph it. But you need to get the equation. Which equation, right? Just looking at the directrix. Now there is a way to remember. h comma k is 1, 8. Okay, this is given. Whenever directrix y is 3, this is directrix, just remember to use the equation also y. If this was x, then use the equation x. That's how we can remember. X minus h the whole square plus k. Now, what do you know here? We do not know a. We know h is 1, the whole square plus k is 8. And this is y. Now, how can you find a? What is the formula for directrix? If you recall, focus is k plus 1 by 4a, whereas directrix is k minus 1 by 4a. That is equal to what? 3. If it was focus, we write k plus 1 by 4a, that is equal to whatever the value is given. If directrix y is 3, this is the formula. It's minus. Always directrix will be minus. You can go back to the set of the formula table and check this. This is the formula. Now, k is 8 here. 8 minus 1 by 4 times a equals 3. Now we can solve this up. Here it's minus, we take this to the other side, it'll be 8. Now you can put in the calculator and get the answer directly. 8 minus 3 is 1 by 4a. 8 minus 3 is 5 equals 1 by 4a. Swap it up. A will be equal to 1 by 20. So the equation must be y is equal to 1 by 20 into x minus 1 the whole square plus 8. That is the equation for this given details. Now you can see the answer here. Okay, after graphing, here you go 1 by 20, 1 minus x minus 1 the whole square plus 8. Graphing we just did, you just use the table and then you can graph it out. So that is the answer here. Now I'm not going to show this because it's the same thing, just like what we did. You need to look into the vertex. What is the vertex here? 1. So take some values less than 1. You can take over here, its scale is 2, so 1 is somewhere over here. You can take 0, minus 1, minus 2, minus 3, and positive 2, 3, 4, 5, and then just graph it up. Only few points are enough, just a simple curve. Now directrix is x and the focus is given. We do not have vertex. So now this is a little bit tricky. Let's see. Here directrix is x. So the formula here used is x is equal to a into y minus k the whole square plus h. Focus is vertex is always h and k. But here we have focus. So it is not going to be h and k, it will be h plus 1 by 4a, comma k. Why? Here x value varies. Look at the graph if it's something like this. This is the vertex, this is the focus. X value is varying, right? So h is added. Now this directrix x directly got, guys, in the exam you need to write given, the steps, the formula, and then all detail. Now I'm just solving it up directly. Now here what we do is directrix x is equal to minus 6, isn't it? So let's write the formula here. That is going to be h minus 1 by 4a. That's it. If it was focus, it's plus, over here it's minus. Now only confirmed value we have is the k value. So x is equal to a is unknown, y minus even k is known. K is the confirmed value, that is minus 4, right? This is something, but this is k, it doesn't change. So here we will just, okay, now y minus of minus 4 whole square plus h, that's unknown. This is y plus 4 the whole square. Only this is known. We do not know the a value and h value. How can we find it? See here, we know directrix. See, this much is minus 6. So let me just equate that equation. H minus 1 by 4a equals minus 6. Whereas h plus 1 by 4a is minus 4. What I will do is, I need h, isn't it? So I will just rearrange and take this to the other side. Sorry, I need a and h. Okay, I need both of these values. So it's up to you to choose, but it's more easier if I just keep h alone over here. It'll be minus 6 and this will be plus. So I'll just write the first term as plus. This will be 1 by 4a. This is positive now, minus 6. I will use the second formula which we know, h plus 1 by 4a, that is equal to minus 2. This is equal to minus 2. Now we will, now it's not about rearranging. See here, I know h value is so much, so why don't I substitute that over here? I'll just substitute h value as 1 by 4a minus 6 plus 1 by 4a, that is equal to minus 2. Now, in order to avoid more steps, I'll just use the calculator here, and it's absolutely fine to use the calculator. I'll just type this out. 1 by 4a, that is alpha x, minus 6 plus 1 divided by 4a. I'll also solve it manually in a minute, but this is how we do it in the calculator. That is equal to minus 2. Now that is, okay, let me, yeah, it's shift and solve and then press equal to. A is 0.125. I'll just press answer and equal to, it's 1 by 8. So I got the A value as 1 by 8. I'll write over here x is equal to 1 by 8. But how exactly do we solve it manually? Here we have 1 by 4a, 1 by 4a. Add this both, will be 2 by 4a. This minus 6 to the other side will be plus 6 minus 2. Now this is going to be 1, 2. It'll be half is equal to 6 minus half a. Over here is equal to 6 minus 2 is 4. Take this 4 to the other side. It'll be 1 by 2 times 4. That is equal to a. That is 1 by 8. That's how we do it. Please write it in steps in detail. Now y plus 4 whole squared. What is h? Here h is equal to 1 by 4 times 1 by 8, because a is 1 by 8. Minus 6. You can just put this in the calculator directly and you'll get the answer. Let me show you here. So I type it out. 1 by 4 times a is again 1 by 8 minus 6. Don't put any x or anything, just type it out as it is and put equal to, it'll be minus 4. The h value is minus 4. Or let's solve it over here. 1 time, it's 2 times, and this 2, what happens, jumps up because it's in the denominator. So that will be equal to 2 minus 6, that is minus 4. So that's the answer. So this is the equation. Now when we have vertex, it's very, very easy. But when we have focus and directrix, it is a little bit lengthier. So that's the answer. You can see that's done over here. Same thing. And finally we get the answer here. It's 1/8. Now y plus y, because it was minus minus, that'll become plus 4 minus 4. The whole square is there. And now what about the graph? Of course, we can use a calculator to graph it by table method, but we have to remember a few things. Here, when we write the equation, it is in terms of x, right? X is equal to 1 by 8, y plus, all this equation. But in our calculator, we only take f of x. That means it considers this to be y. So when you input, it will be y is equal to 1 by 8 into x plus 4 the whole square minus 4. You have to put this in calculator. But just remember, whatever answer you get is the other way around. It's not x and y, it's y and x. Now what values you'll give for y? That will be here given for x. What values you give for x will be for y exactly. So here, where is the vertex? Vertex is, okay, now in this equation we can see what is the vertex. H and k, right? This is minus 4. Sorry, this is minus 4. K is minus 4 and H is also minus 4y, because it's plus minus becomes plus. So this is the vertex. Just getting the vertex out of this. The standard form is y minus, here it is minus k the whole square plus h, right? So h is minus 4 directly, but here if it's plus we write the opposite sign, whereas it's minus we write plus 4 here. So we write minus 4. So this is the vertex. It's minus 4 here. Now we are not dealing with the x value, y values, because inside values we are going to assume, right? We're going to give it to the, in this table, it's not x, y. Now it's y and x. So y to be assumed. What is y over here? Okay, minus 4. So minus 4 is here. We'll take minus 3, minus 2, and over here we will take minus, lesser values than minus 4 is minus 6, minus 5, minus 3, minus 2. These are enough. Now let me show you how to put in the calculator. Let's just go to mode 7. Now this is the equation, but when you type it out, it's 1 by 8. You open the brackets. You can't put y as variable. It is x itself. The whole squared minus 4. Now when you press equal to, ignore this. Start. Where do you start? At minus 6. End it at minus 2. And step is 1. Here we go, the values. Now what is this x value? X is actually the y-axis, because over here it's flipped, isn't it? So x is minus 6. That doesn't mean it is exactly here minus 6. X over here minus 6 means this is the point. Minus 6 is how much? Minus 3.5. Is it correct? Yes, it's minus 3.5. Then we have minus 5 over here. Yes, it's minus 3.87. Minus 4 is minus 4. And you can scroll down. It should repeat itself. You can see here at minus 2. That's somewhere over here. It is minus 3.5. Yes, it's in the middle, and so on. This is how we get the graph, and then just join these points. Enough. Only few points are enough. That is the equation. I hope it is clear. Now here again, focus and directrix. See, exactly like the same previous one. Focus and directrix, focus and directrix. So you have to do this by yourselves. There's no difference in this. You need to find the a value, and then you will have to find h value, and then substitute in the equation, and you get it. Literally the same like 28. Only the thing is the a value will be negative here, because the sign over here is x is equal to 10, 2 and 4. When you solve it up, you get a negative. It's opening leftwards. That's the only thing. Now vertex and directrix is there. Whenever vertex is there, it's easier. Why? Because this is h and k. Directrix, the formula over here, the x is there, so it's x into a in multiplied by y. It's not h, it's minus k, the whole square plus h. Here, what changes? Again, if you get confused, just look at the graph. Okay, this x y value will remain same, x value changes. So x will be the plus and minus. So over here also this is there. H is basically h. Directrix is minus 1 by 4a. And you know what is h value. So what I'll do is equal to 2. H value is minus 6 minus 1 by 4a is equal to 2. Let me take this to the other side. Minus 6 minus 2 is equal to 1 by 4a. And just take it to the, solve it up. Here minus 6 minus 2 is minus 8 equals 1 by 4a. A will be equal to 1 by 4 times minus 8. That is minus 32. That is a value. 1 by negative 32. You can just put this entire thing in the calculator and still you will get the same answer, and you can skip it. No problem at all. After this, we'll substitute in this formula. A value is 1 by 32. It's minus y. What is k value? Here it's 0. The whole square plus. What is h value? It's minus 6. And we can just simplify minus 1 by 32. Y power 2 minus 6. That is the equation, and it starts with x. So here we go. When we solve it up, it's minus 1 by 32 y squared minus 6, and then you can just solve this up. You don't need to find latus rectum, but latus rectum is 4 times a. 1 by this, 1 by a. A is there, right? 1 by 4a. Just take this value. But all we have to do is write the equation, so you don't need all this stuff, because graphing we are doing by table. You can just ignore this altogether. Just do it by table, get the vertex and get it from the table. Vertex and focus, we have done this problem. Now what you do is see here what is same. X is same. What is changing? Y is changing. That means it's vertically aligned, isn't it? So here we have HK. H is same. K is plus 1 by 4a. Always focus will be plus, directrix will be minus. Now this is y equals a into x minus h the whole squared plus k. This is the formula. A is unknown, but what is h? Minus 9 the whole squared plus 6. And now what we do is we find a value. We know k plus 1 by 4a will be equal to 5. And k value is already given to be 6. That is 6 plus 1 by 4a equals 5. 1 by 4a equals 5 minus 6. So 1 by 4a equals minus 1. Swap it out. It'll be 1 by 4 negative, that is equal to a value. So this is the answer, minus 1 by 4 x minus 9 the whole squared plus 6. So that must be the equation, and then you can easily graph it out. So here you go, it's minus 1/4 x minus 9 plus 6. Yes, that's the same thing. And we know how to graph it. We can just use the calculator and graph by table method, mode 7. Here, since the a value is minus, it opens downwards. If it was positive here, it would open upwards. Same thing, if it's positive along the x, like this equation, plus a, it opens right, otherwise it opens left. In this video, we will find the angle between two vectors. It's from the lesson 7.5. Here we have been given two vectors. There are 3 dimensions. So it will be x1, y1, z1 or z1, x2, y2, and z or z2. What we need is the angle. So we know the angle formula. It's really cos theta equals u dot product v divided by u magnitude multiplied by the magnitude of v. This is the formula. This is dot product. This magnitude just normal multiply, scalar multiplied with the dot product of v. So when we take cos to the other side, it will be cosine inverse of this particular answer. But what else do we want? What is required to find the theta? The dot product and the magnitude. So what are the formulas for dot product? It's just x1 times x2 plus y1 times y2 plus the z1 times z2. And then this is it'll be a single quantity, whatever we get over here. What is the magnitude? Magnitude will be, for u, it is x1 I have taken, so it'll be x1 squared plus y1 squared plus z1 squared. It's not over, we have to take the square root as well. And lastly, v magnitude would be the same thing, but it's second, z2 squared plus y2 squared plus, so x2, y2, and z2 squared. This is it. These are the formulas. This is the main formula. Let's solve one by one. In the exam, write the formula here, and then under it, just do the substitution and solve it up. I'm just going to do the substitution here because it's already written over here. So it'll be 3 times 1 plus minus 2 times 4. I'll put brackets for negative numbers. Plus 2 times minus 7. You just put in the calculator, you will get the answer. What about the magnitude of u? It's 3 squared plus minus 2 the whole squared plus 2 squared the whole square root. V would be square root of 1 squared plus 4 squared minus, sorry, it's plus of minus 7 squared. Once you solve over here in the calculator, see, you need to write the formula, you need the substitution. In the exam, you can do like this. Step 1, dot product. Okay, you can just write dot product. Step 2 over here would be magnitudes. Magnitude of u and v. You can write dot product of u and v vectors, magnitude of u and v vector. Write the formula, substitute, answer. Even over here, write the formula, substitute, answer. Then step 3 would be angle of the vectors. Angle theta is required of between the vectors or of the vectors. Over here also the formula will be theta equals cosine inverse of u dot product v by u magnitude multiplied by v magnitude. That's it. Here we need to substitute what answers we get up above. So let's take our calculators and solve. We need to type this out. 3 times 1 plus bracket minus 2 times 4 plus 2 times minus 7. Close the bracket, equal to negative 19. So here it's minus 19. Now what about the other two magnitudes? It's square root of 3 squared plus, see, minus 2 the whole square will become positive. So you can avoid writing minus, just write the value, it's fine. Because you're squaring it, it'll be only positive. It's square root 15 here. What about this? Square root 1 squared plus 4 squared plus, I'll just write 7 squared because it's going to be positive anyways. It's square root 66. Now all you do is substitute everything together. That's square root 15 multiplied with square root 66. And here we go. The final answer will be shift and cosine. It is minus 19 divided by square root 15 multiplied by, use just this multiplication, square root 66. Make sure you go next and type the multiplication, because after you write 66, if you put multiply, it will be inside the square root. Then close the bracket here, not over here, press next, and now close the bracket. The answer is 127.14 degrees. That will be the final answer. Theta equals 127.15 degrees. I've just rounded off the, oh look over here, nearest tenth. Rounded off to the nearest tenth. It'll be 1 itself. 127.1 degrees. So that's the final answer. I'll do one more problem with more detail. I'll write exactly what you must write in your exam. So these are the values which we also got. Okay, there was a mistake here. It's square root 17. All the other values are all right. Let me just check again. Let me just change this to square root 17. The answer is supposed to be this. Let me solve. Square root 3 squared plus 2 squared plus 2 squared. It's square root 17. My bad. I missed out a number, I believe. I don't know what did I do wrong. But anyways. So answer is not square root 15. It's 17. See, this is the correct answers. And then you put it in the calculator with all these values. And over here we get the answer. Now nearest 10th, it was 124.55, which corresponds to 124.6. Let me do one more answer. Let me do this thoroughly. Step 1, if you're doing it for your exam, step 1. Find the dot product. Dot product. Here it is u dot v, that is given as x1 plus, sorry, x1 times x2 plus y1 times y2 plus z1 times z2. U dot product v will be equal to, this is x1, 6 times minus 8 plus minus 5 times minus 9 plus 1 times 5. And you just put in the calculator, you will get it. Next, step 2 is magnitudes. Magnitude of vector u and v. So magnitude of u is given as square root x1 squared plus y1 squared plus z1 squared. The answer is square root 6 squared plus minus 5 the whole squared plus 1 squared. And here the magnitude u would be this final answer. What about v? The magnitude v would be x2 squared plus y2 squared plus z2 squared. And all you do is substitute the values. It is minus 8 the whole squared. When you're writing it, make sure you write the minus as well. But in the calculator, that is not required. You can just put the number of values. Then lastly, we have step 3, angle theta between the vectors. You make sure you write BETWWEN between properly. This is short form. Theta is equal to the cos inverse of u dot product v divided by the magnitude of u, the magnitude of v. So now we will use our calculators and find the values of all these things. Starting with the dot product, it is 6 times minus 8. I'm not going to write the brackets because I know it will work with multiplication. Plus, say it's minus 5 times minus 9 plus 1 times 5. It's always good to write the brackets, but let me show you. Without the brackets, it's 2. Even with the brackets, it'll be the same answer. Here it is minus 5. Let's just... But it's always a good habit to use the brackets. In some cases, brackets are very important. Here it's 2. Dot product is 2. That's done. So what about magnitude now? Here it is 6 squared plus 5 squared. These values, just, I'm not going to use any negative numbers or anything. I'm just going to use the values only. It's square root 62. Square root 62. And what about the next one? Here it is again square root of 8 squared plus 9 squared plus 5 squared. The answer is square root 170. Then put it all in the calculator over here. For cos inverse, dot product is 2 divided by square root 62. Go next and then put the multiplication symbol, square root 170. Go next and another one next to come up over here. Close the bracket. The answer is 88.88. Here 88.9 degrees because it's to the nearest tenth. Over here, don't forget to write the substitutions. 62 multiplied by 170. And that's the final answer. The angle is 88.9 degrees. So here we go. That's the final answer. So make sure you write the steps. Not only this, it's better to write the steps which I have written, the 3 steps, and then you'll be awarded the full marks. Similarly, please do try these problems by yourselves because there's nothing difficult in this. It'll just be the same thing. Over here, the answers are visible. Even over here, try the same thing. 0, it'll just be easier to calculate. No need of substituting all of it at once. I would suggest you do the steps. Step 1, step 2, and then do the final answer. It's more better like this rather than doing all at once, because if you miss something over here, then it's a big hassle. 14th one. Here, just remember to take the first part as x1, x2, and x1, y1, z1, and so on. Here as well, it's the same thing. You can first find the dot product, then you find the magnitudes, and then put it all in the cosine formula, the theta angle formula. And here we go, that'll be the answer. No, that's not the answer. This is the answer, nearest tenth. Let me do the last problem here. First of all, remember this is x1, y1, z1, x2, y2, z2. I'm not going to write the formulas and everything. I'll just directly write the answers. So u dot product v will be minus 6 times minus 4 plus 3 times 2 plus 5 times 6. Magnitude of u would be square root of minus 6 the whole squared plus 3 squared plus 5 squared. Magnitude v would be square root of minus 4 the whole squared plus 2 squared plus 6 squared. So lastly, cosine inverse of theta is equal to, the angle is u dot product v by u v. That's the answer. So here what I will do is just put this all in the calculator and substitute in the final formula. Dot product minus 6 times minus 4 plus 3 times 2 is 6, plus 5 times 6 is 30. Here we go, answer is 60. That's the first one. So this is going to be cos inverse of 60 divided by, what is the square root of 6 squared plus 3 squared plus 5 squared? It is square root 70. And lastly, we have square root of 4 squared plus 2 squared plus 6 squared. The answer is 2 root. Now this is 2 root 14. Why? Because 2 is taken out common. It is 14 times 4 actually, That is also fine. However, whichever the answer you get, whichever form, doesn't matter. You just write it as it is. 70 times 2 times 2 square root 14. Now we'll just put that all in the calculator. Cosine inverse of 60 divided by square root 70 times, press next and then multiply it with 2 square root 14. Close the bracket. This is the answer. Make sure your calculator is in degree mode, because if it's in radian, see, imagine you kept it in the radian mode, the answer is absolutely wrong. So shift more and 3, or just clear your calculator. The default mode is always degrees. So 16.6 must be the correct answer. Yes, that's the correct answer. And that is the end of all the writing part questions. I hope you have found these videos helpful and beneficial. I wish you all the best for your exams. Please do prepare well in advance for your exams. Don't leave it at the last minute. And if you have any doubts, please try re-watching the video or ask your questions in the comments, and I'll try to get back to you very soon. And thank you very much for your support for my channel. I'm really humbled by all the appreciation and thanks I receive on the channel. Thank you so much. I really appreciate it. If you could do me a huge favor, then please do share this channel with anyone who do not know about this and who could benefit from it. And if you can, please do hit the subscribe button and like my videos. It would mean a lot. Thank you very much, and bye-bye for now.